Founded in 1984, Chroma ATE Incorporated, marketed under the brand name Chroma, is a world-leading provider of test and measurement technology, automation integration, intelligent manufacturing system, and test and automation turnkey solutions. Over the last decades, Chroma has grown significantly into Chroma Group, covering semiconductor and wireless testing, automation, AI, EV powertrain, and digital signage. Now, there are 9 major companies under Chroma Group operating worldwide, exceeding 3,000 employees. Chroma's market focus has evolved with global technology trends. We began in the IT industry and progressed to semiconductor and communication test solutions. When green energy became an issue, our test applications expanded to clean tech industries. We've since entered new markets for AI, advanced packaging, energy storage, and life science, where the growth opportunities lie ahead. Significant markets served by Chroma include semiconductors, photonics and LED, photovoltaics, video and color, flat panel display, power electronics, passive component, electrical safety, green battery, electric vehicle, thermoelectrics, automated optical inspection, and intelligent manufacturing system for ICT and cleantech industries. Chroma's vision is to empower future technologies for a better world. We believe in the truth of measurements and the trust of partnerships. Using the most advanced solutions, we test and measure the quality of clients' products with the ambition of making them better, more effective, and ultimately thriving in the marketplace. By delivering truth in constructive, open, and trusted partnerships, we enable the development of innovative products for the betterment of society and the world. Chroma enables quality innovation at every step with reliable solutions. We have developed more than 100 core technologies that serve as cornerstones for new technology development, with more than 1,000 patents worldwide. Chroma nurtures its brand as one of innovation, collaboration, and trustworthiness to ensure the performance, quality, and success of technology industries. With continuous leadership in high power and high precision technologies, Chroma gains its competitive advantages. Chroma's performance has been recognized with several honors and awards, including Best Mid-Cap Company, Distinguished Taiwan Mittelstand Award, Distinguished Enterprise Innovation Award, Harvard Business Review Taiwan Top 100 Best Performing CEOs, Semi-Industry Contribution Award, and Top 40 Best Taiwan Global Brands. Chroma has branch offices in Europe, the United States, Japan, Korea, China, and Southeast Asia, where we support customers with local value-added service and unique test and automation turnkey solutions in the fields of e-mobility, communication, and green energy, making our everyday life greener and smarter, now and in the future. Chroma, advancing excellence.
Tiap hari, di tiap SPBU, selalu ketemu banyak orang. Ada yang lama dan yang baru. Ada yang sempat senyum, ada juga yang buru-buru. Semua ada ceritanya yang ngasih energi buat gerakin hari-hari kita. Seringnya energi itu muncul dari yang sederhana. Bisa jadi dari yang kecil, tapi ngebesarin semangat. Atau hal-hal yang gak terduga, tapi ngubah sesuatu di dalam diri. Dan gak cuma di daratan. Di laut, ada cerita teman-teman yang bergerak bareng nelayan, ngejaring berkah. Di bandara, mereka yang selalu sigap buat nerbangin energi di udara. Saya rasa bahkan di detik ini pun, pasti ada aja energi mengalir yang jadi penyemangat buat terus melayani sepenuh hati. Nimbulin rasa dekat, punya sobat di tiap perjalanan, sepanjang Indonesia. 68 tahun dan berkelanjutan. Pertamina, Energizing Indonesia.
Sentra Surya Ekajaya, also known as SSE, is a leading Indonesian private company that specializes in designing, engineering, and manufacturing tactical and multi-mission vehicles. Our product lineup includes the all-terrain assault vehicle, armored reconnaissance vehicle, and armored personnel carriers. With more than 20 years of industry experience, SSE has achieved remarkable success in the production and enhancement of a diverse array of vehicles, which caters to the requirements of military applications, both domestically and internationally. Additionally, the ballistic protection of our vehicles could be upgraded based on the user requirements. Our engineers have broad expertise in product design, industrial processes, mechanical engineering, electrical engineering, and mechatronics. Human-centered design is the backbone of our work process and our core principle towards creative problem solving. It begins by actively listening and thoroughly understanding the conditions and pain points that vehicle users frequently encounter during their missions. We then identify the operational requirements and focus on engineering solutions that are tailor-made to meet their specific needs. We also operate a fabrication facility where we shape, bend, and cut raw materials into precise parts using various digital machinery, such as CNC milling, bending, and laser cutting. Our manufacturing department is supported by mechanics and assemblers with exceptional skills. The manufacturing process begins by constructing a tubular frame on the jig. After positioning all the tubes, each joint is meticulously welded together. The welding unit is supervised by welding inspectors who holds both national and international certificates, while also equipped with a customized welding machine that complies with Industry 4.0 standards. Our welding machine features a real-time remote monitoring of welding quality and secure digital data storage of WPS and production logs in cloud server. After the welding process, the vehicle frame will undergo sandblasting, which involves spraying abrasive materials at high pressure onto a surface to remove contaminants like rust, paint, salt, and oil. After rigorously cleaning the surface of the vehicle frame, it is prepared for the application of a sophisticated primary coat and top coat to ensure longevity for decades to come. As we proceed to the essential assembly phase, we meticulously fit and install the main engine onto the vehicle's frame. This critical step ensures that the heart of the vehicle is securely in place, ready to power its future endeavors. Once the engine is perfectly installed, the assembly process continues with the
Recognizing the importance of environmental preservation is not only necessary. Beyond that, fundamental changes in how we perceive and treat the environment are required to achieve a sustainable future. As the main pillar of the Indica Energy Group, we are committed to achieving net zero emissions by providing sustainable integrated engineering solutions. Since 1973, we've been a driving force in developing Indonesia's national industries across diverse sectors like new and renewable energy, petrochemicals, metals and minerals, power and industrial plants, and oil and gas. Empowered by our vision to engineer sustainable solutions that transform energy and accelerate downstream, Tripatra continues to thrive in addressing future challenges. In the midst of the new era of energy transition and green energy, Tripatra strides boldly forward, presenting a tangible embodiment of our commitment to providing green solutions, emphasizing the spirit of sustainability. Leveraging the experience and multidisciplinary engineering expertise of our engineers, Tripatra does not only develop innovative solutions, but also weaves the journey of energy transition towards a future powered by green energy, guided by our commitment to the principles of environmental, social, and governance, ESG. With every step we take, we strive for a future where business thrives in harmony with nature, society, and responsible governance. We uphold our commitment to continuously deliver the innovative integrated engineering solutions, preserve a sustainable environment, and create meaningful impact for society and the future of our nation. For a sustainable future. Tripatra, envisioning, engineering, empowering.
PT Vale Indonesia telah menerapkan operasi pertambangan berkelanjutan di Blok Sorowako, Sulawesi Selatan.
Founded in 1984, Chroma ATE Incorporated, marketed under the brand name Chroma, is a world-leading provider of test and measurement technology, automation integration, intelligent manufacturing system, and test and automation turnkey solutions. Over the last decades, Chroma has grown significantly in Chroma Group covering semiconductor and wireless evolved with global technology trends. We began in the IT industry and progressed to semiconductor and communication test solutions. When green energy became an issue, our test applications expanded to clean tech industries. We've since entered new markets for AI, advanced packaging, energy storage, and life science, where the growth opportunities lie ahead. Significant markets served by Chroma include semiconductors, photonics and LED, photovoltaics, video and color, flat panel display, power electronics, passive component, electrical safety, green battery, electric vehicle, thermoelectrics, automated optical inspection, and intelligent manufacturing system for ICT and clean tech industries. Chroma's vision is to empower future technologies for a better world. We believe in the truth of measurements and the trust of partnerships. Using the most advanced solutions, we test and measure the quality of clients' products with the ambition of making them better, more effective, and ultimately thriving in the marketplace. By delivering truth in constructive, open, and trusted partnerships, we enable the development of innovative products for the betterment of society and the world. Chroma enables quality innovation at every step with reliable solutions. We have developed more than 100 core technologies that serve as cornerstones for new technology development, with more than 1,000 patents worldwide. Chroma nurtures its brand as one of innovation, collaboration, and trustworthiness to ensure the performance, quality, and success of technology industries. With continuous leadership in high power and high precision technologies, Chroma gains its competitive advantages. Chroma's performance has been recognized with several honors and awards, including Best Mid-Cap Company, Distinguished Taiwan Mittelstand Award, Distinguished Enterprise Innovation Award, Harvard Business Review Taiwan Top 100 Best Performing CEOs, Semi-Industry Contribution Award, and Top 40 Best Taiwan Global Brands. Chroma has branch offices in Europe, the United States, Japan, Korea, China, and Southeast Asia, where we support customers with local value-added service and unique test and automation turnkey solutions in the fields of e-mobility, communication, and green energy, making our everyday life greener and smarter, now and in the future. Chroma, advancing excellence.
Tiap hari, di tiap SPBU, selalu ketemu banyak orang. Ada yang lama dan yang baru. Ada yang sempat senyum, ada juga yang buru-buru. Semua ada ceritanya yang ngasih energi buat gerakin hari-hari kita. Seringnya energi itu muncul dari yang sederhana. Bisa jadi dari yang kecil, tapi ngebesarin semangat. Atau hal-hal yang gak terduga, tapi ngubah sesuatu di dalam diri. Dan gak cuma di daratan. Di laut, ada cerita teman-teman yang bergerak bareng nelayan, ngejaring berkah. Di bandara, mereka yang selalu sigap buat nerbangin energi di udara. Saya rasa bahkan di detik ini pun pasti ada aja energi mengalir yang jadi penyemangat buat terus melayani sepenuh hati. Nimbulin rasa dekat, punya sobat di tiap perjalanan, sepanjang Indonesia. 68 tahun dan berkelanjutan. Pertamina, Energi Indonesia.
Bumi sebagai rumah kita tinggal dengan keanekaragaman hayati sebagai anugerah terindah dari Tuhan yang perlu kita jaga bersama. Salah satu bentuk tanggung jawab kita adalah menjaga agar udara tetap sehat dan menjadikan bumi layak untuk ditinggali. Kegiatan manusia pada sektor industri dan transportasi menghasilkan emisi gas dan debu yang dapat mempengaruhi kualitas udara. PT Eksperta Adi Manusa hadir sebagai perusahaan yang berfokus pada layanan jasa pengujian, kalibrasi, dan konsultansi pada sektor lingkungan dan energi. Kami adalah perusahaan yang sangat kompeten, mengacu kepada standar-standar nasional maupun internasional. Visi kami adalah menjadi pemimpin dalam bidang jasa pengujian, kalibrasi dan konsultansi pada sektor lingkungan dan energi, yang berkontribusi menjaga keberlanjutan dan kelestarian lingkungan. Dengan dukungan tenaga ahli yang kompeten dan pengalaman yang panjang, kami mampu menjawab tantangan yang ada. Laboratorium lingkungan kami telah terakreditasi Sistem Manajemen Mutu ISO 17025. Dan ditunjuk sebagai Laboratorium Lingkungan Rekomendasi KLHK. Laboratorium pengujian kami mempunyai kapabilitas dalam melakukan pengujian lingkungan untuk udara emisi, sumber tidak bergerak, pengujian udara ambien dan pengujian hygiene industri. Kami sangat berpengalaman dan mempunyai kapabilitas melakukan pengujian CHEMS, yaitu RCA test, rata test, CJA, linearity drift test, integrasi sispek, instalasi DAS-DIS dan juga CFD modeling. Laboratorium lingkungan kami saat ini sedang dalam proses melakukan perluasan ruang lingkup pengujian untuk parameter organik, anorganik, mikrobiologi dan logam pada matriks air limbah, air permukaan, air bersih maupun air laut. Kami memiliki laboratorium kalibrasi yang telah terakreditasi Sistem Manajemen Mutu ISO 17025. Laboratorium kami mempunyai kapabilitas melakukan kalibrasi terhadap alat-alat pengujian untuk gas polutan dan debu seperti GGM Isokinetic Console, nozzle, pitotube, temperatur, dan juga flue gas analyzer. Berikut adalah salah satu portofolio kami. Kalibrasi CHEMS di industri smelter dan pembangkit listrik, audit energi di pembangkit listrik tenaga uap, dan inventarisasi emisi. Kami juga mempunyai pengalaman panjang dalam menangani pekerjaan konsultansi lingkungan dan energi. Di antaranya adalah kajian penempatan pengujian CHEMS, manajemen pengujian CHEMS, pertek emisi, pertek air limbah, AMDAL, UKLUPL, audit energi, audit kinerja pembangkit listrik, studi konservasi energi, studi inventarisasi emisi, asbestos assessment dan environmental set assessment. Customer kami tersebar hampir di seluruh Indonesia hingga mancanegara, termasuk proyek audit energi pada PLTU berkapasitas 2x660 MW. Berikut sebarannya. Kami adalah solusi terbaik untuk setiap permasalahan lingkungan dan energi di perusahaan Anda. Hubungi kami melalui kontak berikut.
Our world is a beautiful scene for amazing projects. In order to improve living conditions and pave the way for better business, people create power plants, platforms, links, networks, trains, and cruise liners. All these huge investments in the tallest buildings, the largest wind farms, and in the most demanding of environments require safety, efficiency, and operational reliability. That is why they all have one small component in common. This. Roxtec is not, however, just a piece of rubber. Roxtec is peace of mind. This is a modular-based Roxtec sealing solution for cable and pipe penetrations, thanks to its three main components: the adaptable modules, the frame, and the compression unit. The system protects life and assets against risk caused by, for example, fire, gas, water, dust, pests, vibrations, and electromagnetic disturbances. It can even prevent the risk of explosion and provide solutions for bonding, grounding, and electrical safety. Multi-diameter is the Roxtec invention for flexibility and adaptability to cables and pipes of different sizes. You just peel off layers to ensure a perfect fit. You can seal multiple pre-terminated cables in one opening, use the seal around existing cables, or even reopen it to use the built-in spare capacity. The sealing solution is developed and tested by experts and certified by all major classification societies. This solution can be used on land, at sea, or underground, wherever cables are routed, wherever pipes are installed, and whatever size they are. Roxtec seals are appreciated worldwide by owners, contractors, and designers. Simplify design and installation while reducing the need for materials and logistics. Rockstack cable and pipe seals hold down the risks, as well as the total cost of ownership. The concept includes design and software services, as well as installation training. Customized and complementary products make Rockstack the complete provider of sealing solutions. Rockstack is a global company with a strong local presence, ready to support you in local and international projects.
Ladies and gentlemen, participants of ICSEEA 2026, our conference will begin shortly. We invite you to enter the conference room and take your seats. Thank you. In addition, we would like to also remind the online participants to make sure and to let us know if you have audio or if you can hear us clearly, or if not, please notify us. Thank you very much.
Ladies and gentlemen, ICSEEA 2026 participants, to ensure everyone's safety, we would like to share a safety induction provided by Trembesi Hotel. Please pay attention as I talk through you the slide. We are currently in the Cisagani Ballroom, located on the 6th floor of Trembesi Hotel. Facilities on this floor include male and female bedrooms located on the left side and right side of the ballroom, accessible restroom for person with disabilities located to the left of ballroom, prayer room located to the south of ballroom, and the restaurant located to the north of the ballroom. Trembesi Hotel adopts a green building concept, which includes safety guidelines and facilities. Our security and alarm system are integrated into a control room monitored 24 hours a day. All meeting room, guest room, and hotel areas are equipped with sprinklers, smoke detectors, and public announcement system. In case of fire, this building is equipped with fire extinguisher and hydrants that meet government safety standard, located near the entrance on both the right side and left side. If evacuation is required, please note that there are two emergency staircases on this floor, located to the right and left as you exit this ballroom, leading to the assembly point. Each emergency exit is clearly marked with an exit sign. In case of earthquake, please remain calm. If there is no study table or chair near you, lie down on the floor away from walls and heavy interior objects, and protect your head and neck with your hands. Avoid windows, glass, and heavy furniture. Do not attempt to run during an earthquake emergency. Please stay calm and follow evacuation instructions. Do not use the elevator. If you use a wheelchair, please lock your wheelchair and continue to protect your head. Evacuation team guidance. It is important to follow instruction from our emergency evacuation team, who will be wearing orange vest and are ready to assist you. Please note, there are no scheduled emergency evacuation drills in the near future. Therefore, if an evacuation instruction is given, it is a real emergency. Please follow the emergency instruction from our team.
Ladies and gentlemen, participants of ICSEEA 2026, we would like to remind you again, our conference will begin soon. We invite you to enter the conference room and take your seats. Thank you very much. ICSEEA participants, to ensure our conference will go as expected, we would like to share with you the conference rules. All participants, please make sure mobile phones or other devices are silent. Online participants, please make sure your microphone is muted and only unmute when being asked or very necessary. Online participants, please follow the name format, article ID underscore name underscore topic. One more time, article ID underscore name underscore topic. For example, article ID number 92, presenter name Novi Shaktika, and topic name clean energy. Online participants must activate the camera and use the official ICSEEA 2026 virtual background. Online participants, please choose a quiet and distraction-free location and ensure proper lighting is used when setting up your video. During the parallel session, participants are expected to remain in their respective rooms on standby, waiting for their scheduled presentation. Offline participants, please note that slideshows will be managed by the operator and cannot be presented using your own laptop. Kindly make sure you have shared the correct file. During a preparation of parallel session, the committee will assign you to your respective rooms. Participants may join other rooms as provided by the committee. Lastly, there will be awards of best presenters and best papers, so please do your best. Assalamualaikum warahmatullahi wabarakatuh. Good morning and a very warm welcome to the International Conference on Sustainable Energy Engineering and Application for ICE 2026 or ICSEEA 2026. My name is Novi and my partner here,
Didi.
we are truly honored to be your master of ceremony through the whole agenda of ICSEEA 2026.
Distinguished guests, respected speakers, ladies and gentlemen. Before we move to our first agenda, allow us to greet our honorable guests and participants. Chairman of Research Organization for Energy and Manufacture, BRIN, Professor Cho Supriyadi Alinandar, and all the research center heads and senior officials within BRIN. Chairman of ICSEEA 2026, Lutfi Pratibugibowo, PhD. Honorable keynote speaker and guest from, on behalf of Directorate General of New and Renewable Energy and Energy Conservation, Ministry of Engineering, Energy and Mineral Resources, Republic of Indonesia, Mr. Hendro Gunawan. On behalf of Directorate of Maritime Industry, Machinery, Transportation and Defense Equipment, Ministry of Industry, Republic of Indonesia, Mr. Patia Junjungan Monangdo, and Director of Road Transportation Facilities and Safety, Ministry of Transportation, Republic of Indonesia, Mr. Yusuf Nugroho, University Teknologi Malaysia, Associate Professor Dr. Wira Jazair bin Yahya, University of Strathclyde, UK, Dr. Raket Emekert, Imperial College London, UK, Dr. Dani Pujianto, National Cheng Kung University, Taiwan, Professor Ta Huili, the National Institute of Advanced Industrial Science and Technology, Japan, Dr. Kiyotaka Tsunemi, Korea Institute of Industrial Technology, Dr. Hong Shik Lee, Katholieke Universiteit Leuven, Belgium, Associate Professor Dr. Teguh Cahyo Widodo, University of Kuala Lumpur MSI Malaysia, Associate Professor Dr. Muhammad Al-Hafiz bin Abdul Razak.
We also would like to express our gratitude to receive support from many parties, especially our general sponsors, whom we would like to also greet today. As the list is quite long, ladies and gentlemen, please bear with me. PT Quantel or Chroma Indonesia, PT Pertamina Persero, PT Tripatra Engineers and Constructors, PT Sarana Laboratorium Instrumentasi or HIOPI, PT Sentra Surya Eka Jaya, PT Vale Indonesia Tbk, PT Experta Adi Manusa, PT Astra Honda Motor, PT Giga Inovasi Nusantara, PT Praxis Automation, PT Roktek Oaktek Nusantara, PT Pertamina New and Renewable Energy, PT Geodipa Energy, PT PLN Nusantara Power, PT Pelindo Terminal Peti Kemas. Please give applause to all the sponsors. To our co-organizer, Universitas Pembangunan Nasional Jakarta, Institut Teknologi 10 November, Institut Teknologi PLN, our publisher partners, AIP Proceeding, Evergreen Journal, Mechatronics Electrical Power and Vehicular Technology Journal, and our event organizer partner, Numedia Atria Dinamika. Lastly, we would like to welcome all the presenters and participants, both offline and online, to be with us today. Let's give our warmest applause for everyone. ICSEEA guests and participants, this conference is organized by the National Research and Innovation Agency of the Republic of Indonesia, BRIN, and is held on February 3rd to 4th, 2026, here at Hotel Trembesi BSD City, South Tangerang, Indonesia. ICSEEA 2026 carries the theme Resilient Transportation and Clean Energy, Shaping the Future of Sustainable System.
This conference brings together researchers, academics, industry professionals, and policymakers from various countries to exchange knowledge, share research findings, and discuss innovation toward a more sustainable and resilient future. Ladies and gentlemen, before we begin today's program, please allow us to briefly explain the flow of this opening session. This session will begin with the national anthem of Indonesia, followed by a welcoming dance, conference report by conference chairman, and welcome speech by chairman of Research Organization for Energy and Manufacture BRIN. And the opening session will conclude with a photo session.
Ladies and gentlemen, as our respect to the host country of ICSEEA 2026, we would like to sing the national anthem of Indonesia. Ladies and gentlemen, please raise. Indonesia Raya. Ladies and gentlemen, please be seated.
Indonesia, as a multicultural country, boasts a wide variety of traditional dance. Today, we are in for a treat as we enjoy a vibrant ondel-ondel dance from Jakarta. Brought to you by the talented South Tangerang 8 Junior High School team.
Ondel-ondel dance is a traditional Betawi ethnic group dance from Jakarta, inspired by the iconic giant puppets known as ondel-ondel. The dance features lively, energetic, and expressive movements, usually accompanied by traditional Betawi music such as tanjidor or gambang kromong. Historically, ondel-ondel symbolize protection from misfortune in the community. Today, the ondel-ondel dance is commonly performed at cultural festivals, traditional ceremonies, welcoming events, and celebrations, representing joy, unity, and Betawi cultural identity. Ladies and gentlemen, please welcome Ondel-ondel Dance. Give the warmest applause to South Tangerang 8 Junior High School Dance Team. One more time, let's give them the warmest applause to the dance team of South Tangerang 8 Junior High School. Wow, amazing. I really like the performance. I'm really impressed. Do you like dancing?
Yeah, they are so young yet they are so talented.
Yes, and they're maybe second grade or first grade of junior high school. So still very, very young. So, well, I hope you all enjoy it. Shall we move to next agenda?
Definitely.
All right. Ladies and gentlemen, to know more about ICCEA 2026, let's listen to the conference report by the chairman of ICCEA 2026. Please welcome Dr. Lutfi.
All right, so I would like to acknowledge the head of the National Research and Innovation Agency, Prof. Arif Satria, and the head of the Research Organization for Energy and Manufacturing, Prof. Duk Supriyadi Arinandar. I also warmly welcome our keynote speakers, ministry and industry representatives, co-organizers, sponsors, our editorial and review team, and all participants joining online and on-site. I am Lutfi Pratiwibowo from Research Center for Transportation Technology. As the conference chair, please allow me to deliver a brief conference report for International Conference on Sustainable Energy, Engineering and Applications, ICSEEA 2026. ICSEEA is an annual flagship agenda under the Research Organization for Energy and Manufacture, and this year, the Research Center for Transportation Technology has the honor of serving as the host of ICSEEA 2026. We see this as a collective commitment to strengthen impact-driven research, especially at the intersections of transportation resilience and clean energy transition. This year, we convene the 13th edition of ICSEEA, continuing our annual platform for sustainable energy engineering and applications, with the theme Resilient Transportations and Clean Energy Shaping the Future of Sustainable Systems. The theme reflects a clear message: building sustainable systems require both resilient transportation, accelerated clean energy, and green manufacturing, supported by innovation, evidence, and cross-sector collaboration. We gratefully acknowledge our co-organizers, the Faculty of Engineering Universitas Pembangunan Nasional Veteran Jakarta, the Faculty of Maritime Technology, Institut Teknologi 10 November Surabaya, and the Faculty of Infrastructure and Regional Technology, Institut Teknologi PLN Jakarta. Their strong partnership expands our network, enriches the scientific program, and strengthens ICSEEA relevance for both academia and practitioners. So as of 31st January 2026, we recorded that we received about 185 abstract submissions and 176 full papers, indicating approximately 94% conversion to complete manuscripts. For full paper themes, the distribution is for energy, we have about 80 papers. For the manufacturing, we have 47 papers, and for transportation, we have 49 papers. This distribution confirms that energy remains the largest focus, while transportation and manufacturing are also strongly represented. Reflecting today's integrated challenges, supply chain, industry, infrastructure, and mobility that must be efficient while reducing emissions. ICSEEA 2026 also strengthens global networking. We are proud to report that the full papers this year come from 10 countries, with the strongest contribution from Indonesia, alongside Malaysia, Oman, China, Japan, South Korea, United Kingdom, Netherlands, Brunei Darussalam, and Thailand. And our keynote speakers represent the 7 countries. Their participation provides two key values. First, broader scientific perspectives and benchmarking. Second, more concrete opportunities for collaboration. ICSEEA 2026 is designed to connect research, policy, and real-world implementation. First, the keynote session will provide strategic insights on clean energy transition, transportation resilience, and relevant innovation directions. We expect this to set a strong tone for deeper discussions in the parallel session. Second, industrial talks, bringing together industry and government, including the Ministry of Energy and Mineral Resources, the Ministry of Industry, to ensure our conference outlining real needs, strengthening standards and regulations, improving industry readiness, accelerating adoption, and building capacity. Third, ICSEEA 2026 also runs parallel sessions in a hybrid format, both offline and online, to make participation more inclusive and broaden scientific dissemination. I would also like to recognize our editorial team and reviewers who ensure manuscript quality and maintain a reliable editorial process, often behind the scenes yet critical to credibility of our output. Finally, thank you for your presence and continued support. Before I conclude, I would like to express my deepest appreciation to the organization committee, consisting of colleagues from various research centers within organizational research, energy, and manufacture. This cross-center collaboration is what makes ICSEEA 2026 well-prepared, well-coordinated, and ready to deliver impact. And to all participants, let us make ICSEEA 2026 more than a platform for presentations. Let it be a place for real action, building network, initiating collaboration, and shaping solutions that can be implemented. Because the future of sustainable systems will not be built by one institution, one discipline, or one country. It will be built by our shared commitment to work together. Let us prove that today's discussion can become. Enjoy ICSEEA 2026. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Lutfi, for the hot speech. And I'm humbly ask you again to give a warm applause for the chairman and for all the organizing committee that have been working together for the successfulness of this event. To formally open this event, it is our honor to invite the chairman of the research organization BRIN of Energy and Manufacturing BRIN to deliver the opening address. Please welcome Professor Joe.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable guests, representative from the Ministry of Energy and Mineral Resources, Ministry of Industry and Ministry of Transportation, esteemed keynote speakers and invited guests, distinguished academic and research, industry partners, sponsors, and of course the organizing committee and all participants. Ladies and gentlemen, good morning. Welcome to Indonesia and warm welcome to 13th International Conference on Sustainable Energy, Engineering and Application, or ICSEEA 2020. It is great honor for me to stand before You as a making this important event that bring together leaders, experts, and innovators from around the world. On behalf of National Research and Innovation Agency, or BRIN, I would like to express my deepest gratitude to all of you for your participation and contribution to this conference. I am pleased to see so many distinguished guests here today, including members of the government, academia, industry, and research sector, all united in our shared goal of advancing sustainable energy solution for the future. Ladies and gentlemen, we are facing a period of profound global transformation, climate change, energy insecurity, supply chain disruption, and geopolitical uncertainty are no longer abstract issues. They are realistic that directly affect national resilience and economic competitiveness. In this context, ICSEEA 2026 has grown into a vital platform for connecting the scientific, industrial, and governmental communities. This conference is where we can share knowledge, discuss solutions, and collaborate on the most pressing challenge faced in the realm of energy and sustainability. The theme of this year's conference is resilient transportation and clean energy, shaping the future of sustainable system. This captures two critical aspects of our future energy landscape. First, resilient in transportation system. It encompasses safety, reliability, and adaptability to crisis, whether by climate change, natural disaster, or disruption of the supply chain, enhancing safety standards and adapting our transportation infrastructure to the challenges posed by climate change. And number two is transition to clean energy. This encompasses innovation in electrification, hydrogen technologies, sustainable aviation fuel, or outdoor energy efficiency, and the ongoing utilization of our energy system. And number three is digitalization and artificial intelligence. Digital technology and AI play a crucial enabling role from the predictive maintenance and operational optimization to emission monitoring, reporting, and verification. Digital solutions help us improve reliability, reduce costs, and accelerate decarbonization without compromising safety. The Republic of Korea, the United States of America, Netherlands, UK, and United Salam in this conference. This offers a valuable opportunity for networking and collaborative research across the border. It also strengthens our collective ability to address their global challenges and expand the boundaries of knowledge in sustainable energy and transportation. And then the industrial talk are the highlight of the program, providing a unique bridge between the research, implementation, and marketplace. The session will showcase how research innovation and directly contribute to real-world solutions, foster greater collaboration between the research and industrial sector. Additionally, the info of government ministries will enable us to better connect research with the national standards, policies, and strategic roadmap. This integration is crucial for ensuring that our research is not only cutting edge, but also aligned with the broader goal of national and international sustainability agenda. As we look forward to the future, I hope that the outcome of this conference will include first is high quality publication that contribute to body of knowledge and sustainable energy engineering. And the number two is a shared research roadmap with will providing a collaborative framework for future research initiative and the formation of consortia of or working group that will make the start the implementing the solution discussion here. And ladies and gentlemen, research and innovation cannot stand alone. Their impact depend on strong alignment with national policies and regulatory framework. In this regard, we work closely with the key ministry and institution. First is Ministry of Energy and Mineral Resources in advancing the energy transition and clean energy infrastructure. And number two is with the Ministry of Industry in strengthening domestic manufacturing capability and clean energy, green industry and local content. And with the Ministry of Transportation, support safety regulatory readiness and implementation across land, sea, and air transportation mode. When research and regulation move in harmony, innovation reach society faster and more effectively. And ICSEEA 2026 bring together participants and speakers from Indonesia and international partners representing academia, industry, government, and research institutions. This constitutes our strength. Ladies and gentlemen, before we proceed with the program, allow me to express my deepest gratitude through their hard work, dedication, and spirit of collaboration. They have ensured that this conference is done for success and benefit. My apapun ya for the kemudian mencari rotan, cara rotan ilikat jadi anyaman. Maka panitia yang penuh ketekunan antara pimpinan dan kelembagaan. So, in English, into the forest we search for rotan.
Right.
Working together, it forms a fine design. Thank you, committee, for your dedication to make this conference through design. With gratitude to our SWT, I have declared that the 13th International Conference and on Sustainable Energy Engineering and Application, ICSEEA 2026 officially open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Chu. Professor Chu, could you please stay on the stage? And let's give the warmest applause to Professor Chu, our Head of Research Organization for Energy and Manufacture, BRIN. ICSEEA participants and distinguished guests, to capture the memory of today's occasion, we would like to take a group photo. First, please allow us to invite Professor Chu, already here, of course, and Dr. Aam, Head of Research Center for Transportation, BRIN. We would like to also invite Dr. Lutfi, Chairman of ICCEA 2026. And for this first photo group session, we would like to invite all keynote speakers who are here with us offline. First is Mr. Hendro Gunawan from Ministry of Energy and Mineral Resources. Could you please come to stage? And next is Mr. Patia Junjungan Monangdo from the Ministry of Industry. Could you please also join? And then Director of Road Transport Facilities and Safety, Ministry of Transportation, Mr. Yusuf Nugroho, please also join. With Dr. Zainal Arifin from PTPLN Persero, Professor Wira Jazair bin Yahya from UTM, and from University of Strathclyde, UK, Dr. Kurt, and then National Cheng University, Taiwan, Professor Ta Hui Lin, Dr. Tsunemi from AIST Japan, and Dr. Hong Sik Lee from Korea. Okay, we would like to also invite the dancers so that we can have a more decorations. Yeah, some vibrant colors in the photos. So we would like to invite also the dancers. Could you please join? Gentlemen, could you please move forward? Yeah. And dancers, maybe you can have a seat. Maybe sitting better. All right. Okay. So this is the first group photo session with our beautiful dancers over here. Please give applause, ladies and gentlemen, to the BRIN senior officials and the keynote speakers. Maybe you can do a BRIN pose as well, photographer.
Help us, photographer.
Can you guide them?
Instruction.
All right, this is BRIN pose. And smile, don't forget. Say cheese. 3, 2, 1, cheese. Okay. Okay, thank you very much for the first group photo session. For the keynote speakers, you can return to your seats. And for Professor Chu, Dr. Lutfi, and Dr. Aap, can you please stay? We will take another group photo with sponsor representative. And here we would like to invite you one by one by calling the company. And please come, one of you, to be on the stage. Okay. PT Kuantel, Chroma Indonesia. PT Pertamina Persero. PT Tripatra Engineers and Constructors, PT Sarana Laboratorium Instrumentasi or HIOKI, PT Setra Surya Eka Jaya, PT Vale Indonesia, PT Experta Adi Manusa, PT Astra Honda Motor, PT Giga Inovasi Nusantara, PT Praxis Automation, PT Rocktech Oaktech Nusantara, PT Pertamina New and Renewable Energy, PT Geodipa Energy, PT PLN Nusantara Power, and PT Pelindo Terminal Peti Kemas. So, any representative who are available here, could you please join us for sponsor representative? Some of them are quite busy preparing the booth, so maybe
have another one.
Join. But yeah, let's wait for more, I believe. Please start. Anyone else from sponsor representative? All right, maybe you need to move forward more. Yeah, let's have another picture. Photographer, you make sure the dancers are in the frame, right? Okay. All right, so let's have a first take. 3, 2, 1. Oh, sorry.
Oh, sorry.
One more. This part. Yeah, anyone else? That's all. Okay, can we repeat? Yeah. All right, 3, 2, 1, cheese. 3, 2, 1. Maybe BRIN pose, photographer. Yes, one more time, BRIN pose. All right, 3, 2, 1, cheese again. Is that okay? Okay, thank you very much. Please give applause to all the sponsors. Okay, now I would like to invite the photo with audience, although I know that this space is not sufficient for all the audience to join. One more time, yes.
I promise this is the last.
All the sponsor representatives, can you please stay just one more time
Yes.
with the audience, and you can go downstairs. Sorry, down
You can
the
take the
stage,
position downstairs. That
Yeah.
means going
and then you
Sure.
turn your
back to the
position.
station.
Yeah, turn your so that you're facing the stage. Yeah. For dancer maybe bisa. All right. Okay. Okay, we would like to take a group photo with all the audience. One more time. We need to balance a little bit. Sorry. Okay, and shall we ask audience to stand up? Yeah. Okay, ladies and gentlemen, please stand up so that we can see all of you. Hopefully, everyone is in the frame. All right, photographers, are you ready? Is everyone in the frame? Except us. I would like to join though. Go, let's go, Didi. Okay, I'll be here then. I hope I'm not like blocking anyone. All right. Oh, di sini aja. Di sini aja. Ini ya. Okay, I'm one of the dancers. All right. Is it good? All right. Okay. Cheers. Maybe one time, raise your hands, all of you. All right. Okay. Raise your hands. 1, 2, 3. Is that all? Okay. Thank you so much. Please give applause to everyone. Thank you so much for your cooperation. Okay, while waiting, we need to set up a little bit for the next session. Thank you so much for your cooperation for the opening session. And while waiting, I would like to check if you are still focused. I believe most of you are still focused. So to check if you're really following everything here, and then maybe to a little bit energize you, we would like to tell you that we actually have a slogan of this event of ICSEEA 2026. And all right, so we have a slogan of this event, ICSEEA 2026. If you remember the theme, part of the theme is shaping sustainable future. So while getting ready, I would like to record a video of all the audience saying the slogan. Can you cooperate with me? What is the slogan, Pak Chu?
Shaping
Okay.
sustainable future. So
Shape-
it's 3 words.
Shaping sustainable future.
Future. It's
Photographer, can you record the video for this part? All right. Yeah. Shaping sustainable future. Audience at the back side, can you hear us? Can you say as loud as
Well, and if
possible
you can hear us.
and
Yep.
shake this building, okay?
Okay.
With the slogan. Shaping sustainable future. Okay, let's practice. I will count 3, 2, 1, and then all of you say shaping sustainable future. All right? Are we ready? 3, 2, 1. Shaping sustainable future. Oh, we need some movement, yeah?
Yes.
Right. Okay. Move your hand, raise your hand to the air as high as possible. All right? Okay. Is practice one more time or just final? Practice one more time, yeah? Okay. In 3, 2, 1. Shaping sustainable future. Okay. That was really good for practice. All right, one more time, yeah, Didi. All right. Okay. This one is a real one. Okay. We will publish this in the website or somewhere. So very important. Okay. Ready, photographer? All right. In 3, 2, 1. Shaping sustainable future. Amazing audience. Thank you very much. Please give applause for everyone.
Now, ladies and gentlemen, we will continue with our first keynote discussion session. In this session, we will discuss about resilient transportation led by our moderator, the head of Research Center for Transportation Technology BRIN, Dr. Aam Muharam. Please come to the stage. Now, for this session, we have another keynotes. The first keynote is from PT PLN Persero, Dr. Zainal Arifin. The second keynote speakers is from University Technology Malaysia, Associate Professor Dr. Wira Jazair Yahya. And our third keynote is from the University of Strathclyde, Glasgow, Dr. Rafet Ahmed Kurt. And I'm humbly ask you all, please welcome to the stage. Our time schedule today, we kindly ask you to ensure each presentation a maximum of 15 minutes, and the Q&A session will be held and conducted at the end of the session. So thank you very much for your cooperation. Dr. Aam, the stage is yours.
Okay, thank you, Dr. Lydia, Mr. Didi, and also ladies and gentlemen. Good morning, distinguished guests, honored speakers, fellow researchers, and all participants of the 13th International Conference on Sustainable Energy, Engineering, and Application. So, on behalf of the organizing committee, OREM BRIN, it is my great pleasure to serve as your moderator here for this pivotal session. My name is Aam Muharam. So the term we will delve into this morning is both critical and timely: resilience transportation. So in an era of dynamic challenge and rapid technological shift, building transportation systems that are robust, adaptable, and sustainable is not just an ambition. It is necessary for our collective future. So we are exceptionally privileged to have with us here 3 eminent experts. It's bringing a unique and invaluable perspective from industry and academia, and also international research. We will adhere strict to the schedule as the MC said, that we will have 15 minutes for each speaker, and also after all speakers deliver the speech, we will have the discussion. I will give a gentle signal when 5 minutes remain, so I will remind you all, and another when the time is complete, to ensure we follow the rule. So without further ado, so I will introduce our first keynote speaker. So our first keynote speaker will ground us in a national vision of integration. We are honored to welcome Dr. Jainal Arifin, Executive Vice President of Renewable Energy at PT PLN Persero Indonesia, with his distinguished credential in energy, engineering, and project management. Dr. Jainal is at the forefront of powering Indonesia's future. His keynote, Resilient Transportation and Clean Energy, Shaping the Future of Sustainable System in Indonesia, will illuminate the essential link between a green grid and robust mobility, providing a blueprint for national transformation. So we will address the integration of resilient transportation with the broader clean energy ecosystem. Dr. Jainal, so I will give the floor is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, ladies and gentlemen. As request from the committee, thank you for the committee inviting us from PLN for sharing about how we transportation resiliency in terms of the energy perspective. And I have the presentation. Okay, I would like to start with the helicopter view. What initially the problem of energy in Indonesia? So we have this triangle. So in terms of energy, it's not only about the availability, but energy should be reliable. For example, we need electricity 24 hours. If there is interference, so cannot be long time. If there is interference, disturbance cannot be too much, too many, too often. So the energy should be reliable. The second thing is about the economically. We cannot produce electricity, for example, within the high price cost of production. This make our national competitive advantage is not good. So we should produce energy, electricity, and affordable price. And the last thing is sustainable. So we need energy, electricity, not only right now for next 10 years, but maybe forever. So this is the basic dilemma of energy. The energy should be reliable, affordable, and sustainable. And right now, at the same time, we also face the energy transition. What is it? The energy transition in global movement push forward the energy industry by three drivers. Decarbonization, so we should produce electricity by low carbon technology. We will coming very much renewable energy for that, for example. And the second is about digitalization. This era of 4.0, we should utilize digital technology to improve our efficiency, reliability, and our prosumer engagement of consumer. We welcoming the era of also decentralization. So right now, the consumer of energy, for example, electricity, not only consume the electricity, but able to produce by themselves. So welcome to the era of prosumer. This is the challenging issues right now for developing energy and also creating the resiliency of our energy. So the next is about Indonesia context. What the energy resiliency of Indonesia? If we look at the Sangket chart, this on this table, yeah. this figure, we can look at the left side is the fuel resources, and the right side is the offtaker, the consumer. So we can look at that. The gray one is about coal. Most of energy in Indonesia are coming from coal, and mostly used for electricity production and also for industry, and the right side. And the blue one is gas. We have so many gas. Some of that is used for our internal industry, and some of them is export to other country. And the red one is fuel. That's the problem. We already import the fuel since 2008. And also right now, and the blue one, yeah, there's also LPG. We already import at a significant amount and continue to increase. So the problem of Indonesia, actually, we have a huge shortage of fuel, but the problem is we also already import so huge volume of fuel and also LPG. That's the problem. That's make our resiliency less than before. And we can look here that the fuel mostly used for transportation. About 70% of imported fuel is used for transportation, especially for road transportation. Instead of the imported fuel is, make our finance is not good there. It's also the consumption of fuel, fossil especially, is also make our our quality of air is not good. For example, in Jakarta, it's already exceed the guideline of WHO. And also, we can look at the data that imported fuel is already about 15% of government expenditure. So we can look deep dive what kind of imported fuel we already import. Yeah, we can see that consists of three types actually of fuel: the gasoline, the diesel, oil, and also after aviation turbine fuel for airplane. Roughly estimated approximately for the transportation alone, we spend about 12 until 20 billion US dollars. So it is approximately equal to 2% of Indonesia economic growth. So if we can reduce this, so actually we can increase the economic growth of Indonesia up to 2%. That's the fiscal problem of our energy imported from especially for the fuel and also LPG, right? And also we have other problem with the very huge subsidy for both fuel and also LPG, because we still have very big subsidy to our small to our Indonesian citizens, yeah. And also for both for the fuel, for the transportation, for public, and also for the LPG for especially for the cooking. And why this why this make our government is seriously to reduce the imported of the energy? So our government, our top leader is already stated that we should create the energy independence. We should reduce the imported of energy. So next, what the solution? The key is we should utilize more and more of a domestic and sustainable energy. That's the key. What is it? So Indonesia actually already had started the biodiesel mandate. We blend the solar with the bio fuel right now up to 40%. And this year we have ambitious plan to increase up to 50%. And we can look at this figure below that this program is significantly reduced the solar fuel imported. And the second is electric vehicle. We can utilize the domestic energy such as renewable energy to for producing electricity to be consumed for electric vehicle. Right now, Indonesia has oversupply capacity of electricity. So electricity cannot be exported to other countries because we don't have any transmission line connected to our neighborhood, for example. So we should utilize this huge and oversupply capacity for electrifying the electric vehicle through transportation. However, yeah, the program is still have some drawback. For example, we at least have 4 issues right now to accelerate the biodiesel program. For example, about the fiscal burden, because the subsidy is relatively huge here. It's take about almost 16 million ton allocation. So almost maybe almost half is subsidized by government. So this is the burden of our fiscal. And the second is about the CPU price volatility. So the financial feasibility of biodiesel is highly depend on the price of CPU at the market. If the CPU is high, the biodiesel is not feasible, less feasible. And also we have still technical compatibility. If we increase the portion of the biofuel to biodiesel, there is a technical problem at the vehicle, especially for the filtering. And the last thing is about the sustainability. So we need fuel actually need a huge plantation, huge plant, and sometimes make deforestation. Yeah. Recently we have with flood in Sumatra, Aceh, not Sumatra, yeah. So one of the hours is about the plantation. Yeah. And so this is a very also scientific issue for supporting the biofuel industry. So this is the challenging issues we have to develop biodiesel for creating the resiliency transportation using the local domestic energy sources. Dr. Jaina, sorry, we have less than time. Okay. Oh, how about electric vehicle? Yeah, actually Indonesia is starting to adopt electric vehicle, and the number is promising, amazing. Yeah. We can look here that from PLN we have the data that the transaction of EV for a special day like it is 5 times increasing, and also the sales of electricity for the electric vehicle is also increased 5 times. So this is very, very amazing number. So this is indeed, yeah, we also have some several issue for EV adoption. Affordability of price, certainly not about the purchasing price, but about the depreciation cost. Some customers still thinking how much I can resell the cars, the vehicle. Yes, and the second is about the still limited charging infrastructure we have. Then also greatly there is the charging, the instability of voltage and so on. but I do believe can be solved by the such smart charging technology. And also the ecosystem not ready yet, and somewhat acceptance about EV still, like how about this recycle of battery, ring uncertainty, and so on. And also we still need support from government, and certainly the subsidy for the EV stop the late 2024. So this is the comparison between such country, Indonesia, Vietnam, Thailand, and China. Indeed, we can look at to the China as the lead of the EV charging adoption globally in the world. But Indonesia, I think, is on the track to increase the EV adoption comparing to our neighborhood, Vietnam and Thailand. The problem of Indonesia actually about the infrastructure is still limited, and about the pricing of EV itself. Even though right now, for example, the sale of the EV like BYD already surpassed the EV conventional like Toyota in Indonesia. So actually we need to build ecosystem, and we are PLN, Indonesia Electricity Company, already started to build the integrated EV ecosystem, connected all stakeholders for the EV charging station, for the customer, for regulator, for the utility in Vietnam. And we create the EV digital services for connected on all stakeholders. Okay. Indeed, we need collaboration because the homework is big. So we should do collaboration, and we collaborate with everyone who want to develop the EV charging station on Indonesia. This is the map 2 years ago, and right now the number of EV charging is maybe almost double from this from 2024. And this is the roadmap. So we need to accelerate this target. Actually, we want to fill 15,000 until 30,000 until 2030. This is the number we need to invest for this charging station. And also we have several strategy. We create an e-mobility platform. We do incentive tariff. We provide home charging service at home. We create EV marketplace. We also open collaboration for everyone who want to join this EV charging station in Indonesia. And also, we need such innovation. This, for example, we utilize the existing pool of electricity to be small EV charging in Indonesia because we have so many pool of electricity. So we can utilize this for increasing the charging station around Indonesia. I think that's all of my presentation. Thank you. Okay.
Thank you very much, Dr. Jainal, for that comprehensive and strategic overview, and also charting the course for Indonesia sustainable system for energy also and transportation. So our next perspective widen the lens to the regional industrial level, examining the pathway for decarbonization that are most suitable for our context. So I will let me introduce Associate Professor Insinyur Dr. Wira Jazair bin Yahya from University Technology Malaysia. Thank you for your coming. So I believe Malaysia not so far from here, right? So you don't should not have a jet lag. No. So Professor Wira from Department of Mechanical Precision Engineering, right? Mechanical Precision Engineering at University Technology Malaysia. An expert in automotive engineering and energy,
Dr. Wira will tackle the pressing issue of a global auto industry decarbonization. What fits ASEAN countries? This is so interesting. His insight will help us navigate the diverse technological pathway and strategies suitable for the unique economic and infrastructure landscape of Asia. So, Prof. Wira, we look forward for your insight. Please begin. Thank you very much, sir, for your kind introduction. Assalamualaikum warahmatullahi taala wabarakatuh. Very good morning. Thank you to the organizing committee, and thank you, BRIN. Thank you everybody for having me today. Okay, today I would like to speak about global auto industry decarbonization and what most important is what fits ASEAN countries. Okay, before that, I would like to make a disclaimer that this presentation is solely on my own opinion, not my affiliated association, institution. Okay. Okay, as many knows, Toyota Motor Companies is the the largest automotive company in the world in terms of number of vehicle sales. And here is Mr. Akio Toyoda, the former CEO of Toyota Motor Corporation. He made many statements that controversial. In a nutshell, he says that vehicle powertrain should have multiple solutions, not only one solutions. Okay, and he received many criticized as not being green enough. Although Toyota already produced hybrid electric vehicles since 1997, long before electric vehicle has been popularized. Okay, and he still insists that one size does not fit all. Okay, before we proceed, I also list down some abbreviation important for this presentation. Battery electric vehicle, BEV, plug-in hybrid electric vehicle, PHEV, both are considered as electric vehicle. And then hybrid electric vehicle and fuel cell electric vehicle are not considered as electric vehicle because they are both fueled with gasoline, diesel, and hydrogen, right? So internal combustion engine doesn't need an introduction. Okay. So electric vehicle sales increase and dominated by Tesla and BYD, but the giant like Toyota is still cautious about this, and the transition to electric vehicle is not uniform. Since the Paris Agreement in 2016, we are expecting the CO2 emissions or greenhouse gas emission reduce significantly, as shown in the left graph. We are expecting a very drastic reduction of CO2 emission, and the projection is very optimistic, right? However, in the real situation, from 2015 to 2025, 10 years time, the emission actually increased 10%. Although we have a significant reduction during the pandemic, but still we score 10%. Yeah. What happened here is that there are many countries doesn't fulfill their promises, or the strategies to reduce CO2 emission is not good enough, or both. Okay, so the EV sales globally increased. Last year, they score 25% of global sales. If this continue, the projection will continue, by year 2050, the passenger car market will be dominated by EVs, right? And we are expecting, of course, CO2 emission also will reduce as we expected from the Paris Agreement. However, that's not always true. This is because at the tailpipe of electric vehicle, there are zero CO2 emissions, but the
the electric, that charging the electric vehicle is not always clean or green, right? The source will come from many sources lah. Okay. Okay. Unfortunately, many countries in the world still heavily depending on coal, right? As you can see from this graph, the CO2 emissions produced from the coal electric generation is significantly higher than if you are using gas or oil. And if you are using the renewable energy such as bioenergy, solar, wind, hydrocarbon, and nuclear, the CO2 emission considered as zero. Okay. If we are driving the same type of electric vehicle, let's say BYD Dolphin, right? In Iceland or Paraguay, we are going to produce not the same CO2 emission if we drive the same electric vehicle in India because of the grid. So if we drive the same electric vehicle in Malaysia, in average, we're going to produce 212 grams CO2 equivalent per kilometer. And if we drive in Indonesia, 270 grams CO2 equivalent per kilometer. Even the country with highest EV production like US and China, they are producing 258 and 202 grams CO2 equivalent per kilometer respectively. So where we drive the electric vehicle is matter, right? So surprisingly, in case of Malaysia, if I'm driving a good hybrid electric vehicle like Honda City, so the CO2 emission that I produce is 95 grams CO2 equivalent per kilometer, as compared to the same B segment BYD Dolphin, 120 grams CO2 equivalent per kilometer. Even if I drive a small internal combustion engine vehicle, Pro 2 Beza there, I only produce 116, as compared to the entry segment level of battery electric vehicle, 125. If we compare the most efficient electric vehicle, Tesla Model 3 versus Toyota Prius, still Toyota Prius, giving the lower CO2 emission. This is in case we drive in Malaysia. How about if we drive a small diesel vehicle fueled with biofuel? In Malaysia, we have B10, which is biodiesel, 10% blended with diesel. Okay, B10. We going to produce 90 grams CO2 equivalent per kilometer, less than Tesla Model 3 if drive in Malaysia. Okay? And if we have, we don't have in Malaysia, but in Indonesia you have B35, and in the future, near future, you have B50. If you are going to have that, you are going to reduce the CO2 emission more than half from using the Tesla Model 3. This calculation is based on well-to-wheel calculation, not LCA, life cycle analysis. Okay, so what strategy should we use? Should we encourage more small diesel vehicle, or we should promote more biodiesel use in the electrical generation? Okay, well-to-wheel greenhouse gas emission for biofuel is always lower than its normal diesel or gasoline, regardless of the source of biofuel, rapeseed oil, soy oil, even the palm oil. And if we jump into this strategy of using small diesel vehicle, we doesn't have to modify the vehicle much. And then we don't have to fork out money to prepare the facilities or infrastructure. Okay, we can implement it immediately. Let's us look at Brazil.
Brazil successfully replaced the use of their gasoline with their bioethanol from sugarcane. And they already successfully reduced their own greenhouse gas emission by 61%. And this US EPA regarded this as example of successful effort from a company, from a country. So what should we do? Okay, Indonesia and Malaysia, both of us are producing 84% of global palm oil supply. Okay, instead of exporting it to other countries, we should use it locally. And what should we do to improve the efficiency of the all chain, including the diesel engine technologies, the plantation itself, maybe increase the yield, improve the waste management, and so on. Sorry. Okay, thank you. Okay, so there are many emerging technologies for diesel engine. One of the example is the utilization of water in diesel emulsion fuel. This can reduce nitrogen oxides and particulate matter about half, and also improve the fuel consumption about 10%. Okay, the only hindrance of this technology is the stability of the fuel, because water and oil cannot mix together, so they need chemical additive known as surfactant. So this surfactant is usually expensive, but nowadays we have this technology known as real-time non-surfactant emulsion fuel supply system. This device can produce emulsion fuel without surfactant. Okay, and this device need to be installed near to the engine, and the emulsion fuel will be supplied inline online. Okay, of course the performance is same as normal emulsion fuel. However, at low load engine condition, it tend to increase hydrocarbon and CO emission a little bit due to the low temperature at low engine load. What we can do is that in order to mitigate that, we can introduce hydrogen fuel. Usually people will introduce hydrogen at the intake manifold, but other alternative is to introduce the hydrogen nanobubble into the fuel itself. Okay, with this we can improve the hydrocarbon and CO emission, but at the same time we can solve the problem of bringing the heavy hydrogen tank on board of the vehicle. Okay, other emerging technologies, maybe people already know advanced low temperature technology. RCCI can improve 60% of engine efficiency, and PPC can improve 45% of engine efficiency. So there are three takeaways. Grid determines EV benefit. Still many countries are still depending on coal. One size does not fit all. ASEAN countries require specific solution for this region. And small diesel vehicle fueled with biodiesel can cut emission if we implement it now. I don't say that we should stop electrification. I say we need to focus on transportation dominates. Biodiesel dominates transportation. Plus electrification and cleaner grid, plus slowly carbonization of electrical grid. Decarbonization is not about ideology, it is about physics, economics, and local reality. That I end my presentation. Thank you.
Thank you. Thank you, Prof. Ira, for your presentation. That's I see a fascination analysis. Also, you can ask more to consider regarding appropriate technology, or not move 100% to electricity, but we can optimize, yeah, make some other technology, add some technology to the current or existing technology. Thank you so much. So finally, for our final keynote of this session, so we need to jump to Glasgow, United Kingdom. So we cross continent and to understand the resilience in another vital mode of transportation, yeah. From land to sea to maritime technology. Dr. Dapat and McCord, welcome to Indonesia again, yeah, Prof. So yesterday, sorry, so we have still time, yeah, Prof. Ira. Thank you for your extend the time to Dr. Kat. So Dr. Kat is researcher in Naomi. Naomi is the naval architecture, ocean and marine engineering, University of Strathclyde, Glasgow, UK. Dr. Kat will bring an international research perspective on maritime system. So his address will focus on the resilience of one of the world's most critical yet often overlooked transport modes like shipping, yeah, exploring how this global industry is steering towards sustainability and strength in the face of change. So, Dr. Clark, we are eager to hear your perspective, and the floor is yours for the next 15 minutes.
Thank you. Thank you very much, Chairman. And selamat pagi, everyone. Thanks. I'm going to go into a new topic, so I've been amazing two presentations on the energy side of things, which clearly shows how much pressure we are under to clean our energy sources and change, make that energy. But this change will come with a cost. So I will try to show the human part of it and what happens in these big systems when you force change. So before I start my presentation, I just want to start with a personal note. I'm delighted to be back in Indonesia. So I've been coming here since 2016. I was awarded my first project in Indonesia. We worked with, I can see in the audience now, Professor Eko. We did our first project at that time, and since then, non-stop continued doing projects, during which I got a chance to meet amazing people, understand the values of this country, including the food, which I'm very proud of, and the collectivism, respect, and resilience that exists in the Indonesian culture. It is important and intense. I never had a bad experience. And these values, I believe, will be more and more important as we go forward to have more complex systems and etc. So I want to thank again for the organizers, BRIN, everyone to come back here and present it from them. Oh, closer, okay, yeah. Sorry, this one doesn't work all the time. Okay. 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 So just a very brief summary of the projects that we have done. So we started 2016 with Suezin project. We looked at additional boats, how to optimize and improve their performance. So you can see photographs of different projects that we conducted here. And then we looked at the problem of when we are now talking about environmental friendly fuels and etc. But we have ships which, when they come end of life, they are beached and they are causing huge amount of pollution to environment. So with SSRI project, we looked at ship recycling yards in Madura Island and tried to bring international standards into Indonesia. And then we managed to fund together with, this was University of Indonesia, the previous one. Then we managed to bring a Indonesian university partner into a European Union project. So SafeMod project I was maritime coordinator for was received 10 million euros of funding from European Union, and we managed to bring an Indonesian partner into that directly funded by EU, which lasted 3 years. Then we did Skills for Prosperity projects, and now we have most recently postdoctoral researchers project. I don't think it's working anymore. Now we have to go one back. Yeah. Okay, if you can. Okay, so who I am very quickly, I am the director of Maritime Human Factors Center. The center focuses on dealing with anything related to humans in complex systems. Especially we are focused on maritime sector, and we have a history of research near 20 years, which is one of the first human factors research centers and in maritime, and quite famous, obviously. As I said, at the Maritime Human Factors Center, we study most complex components of the maritime systems, not just technology, but not just the regulation, but people. Yeah, so in terms of human performance, when we look at the human performance, humans are amazing creatures. So we can make the most reliable system fail with one small mistake. So the designers may think a lot of things, go through rigorous processes to make sure the system will not fail, yet a human can come on and interact with the system in a way that nobody anticipated and make that system perform differently than originally planned. So this may result in catastrophic outcomes sometimes. And on the other hand, the same human can go into a system which is terribly designed and can make that system work because of the right interventions for that. So there is a paradox in the human performance. Is human error-making mechanism for us, or is human a resilience resource for us? So now the difference between the two is obviously human intelligence, and we are going to need more of that as we go forward. So NVIDIA CEO was interviewed and he was asked who was the smartest person he has met. So he thought a second or two, those of you who watched the interview will remember, and he said, I cannot answer this question because today intelligence is not about scores. So the intelligence definition is changing. Technical ability, empathy, situational awareness, these things are becoming more important than someone scoring high. Yeah. So again, so we take this example to the next level, saying that what used to be considered in the past as software engineering was an ultimate smart profession. But when AI is introduced, the first problem AI solved was software engineering problem. So automatically we are now redefining, or in the transition of redefining intelligence. What is smart? What is intelligence? So human intelligence is going to become more about anticipation, judgment, and context than doing tasks that can be done more efficiently by AI or automation. So this is clearly going to have an impact on how we see the competencies. So intelligence, so who is really smart then? Intelligence is not purely technical ability, and we agree on this now after AI in the production. It is about seeing what others don't see. It is sensing problems before they happen and understanding what is not said. This is where humans are more capable with, so we can deal with this. Obviously, intelligence is changing, so it is the maritime. So if you look at today's maritime systems, we have new challenges coming up. Carbonization, digitalization was mentioned in the first presentation as well. Autonomy, artificial intelligence keeps on coming and integrated into operations at every level, from design to operations. And these, together with the changes, we introduce new risks with alternative fuels, for example, or we introduce or require different levels of intelligence to interact with these systems. We need new competencies to deal with the operational requirements, and the operational contexts will also change. So when you listen Donald Trump, I think he says nobody ever seen before. It's his favorite sentence. So I think shipping is going through a huge transition with a speed nobody ever seen before. If we use Donald Trump quotation. Obviously, it's a fictional quotation created by AI there, but the real question is that are we ready for this speed of change? Because of the pressures introduced, shipping is now rushing into technological improvements, and there will be safety outcomes. So if we see these pressures, obviously now the role of humans are also changing. Humans are now becoming supervisors of automation, coordinators across systems, decision makers under uncertainty, and they are the final layer of resistance. On the left-hand side of the photo, you would see more traditional manual physical work that is being done on ships. And as we go forward now, we start seeing humans' role turning into more interactive with systems and understanding processing information. This is going to require, as I said, different levels of skills. More than muscle, you will possibly need more cognitive capability to deal with multiple information and make decisions. So human factors, because of these changes, is no longer an optional thing. So complexity is increasing. This is a fact. Automation changes. So there are increased numbers of automation used on ship systems. And it does not remove human. Autonomous ships, when they proposed, they said we will make ships autonomous. We won't need human on board. They were wrong. We told them that they were wrong. And now human factors conferences are full of autonomous service because they understood the role changes. And now the changed role is more tricky than the previous one. Treating human factors as an afterthought creates risks, uncertainty, exists at every level. So we need to study this. If we design systems without humans in mind, design failure. So what needs to be understood is human has capabilities and limitations. If we do understand the capabilities and limitations well, then we can design the system around those limitations. So as humans, our attention is limited. We cannot sit down and monitor a monotonous task 24 hours. It's impossible. So if you put a human operator to an autonomous vessel to monitor, when something goes wrong, he or she will intervene and take control. We know that it doesn't work, and they also experience that it doesn't work. Now they are trying to find a solution for this. Memory is imperfect. Our memory has a capability. Humans are sensitive to workload, stress, so there is uncertainty in our performance. But on the other hand, humans are excellent in adaptation, improvisation, and being resilient, dealing with unexpected, which others cannot. So we need to turn human into a resource. So to give you an example,
you have 4
minutes. So to give you an example, cyber attacks now, due to increased digitalization on ships and connectivity, cyber attacks are 900% more happening on ships. So if you get it next, please, I will try to speed up. I'm going to give you an example of a GPS spoofing on ships. So if you just click on the animation. So when a cyber attacker attack on ship with this GPS spoofing, they are basically spoofing the navigational position on the systems of the ship, and the ship captain, what he does is he changes the course if he is equipment oriented to bring the virtual ship into the line. So now the real ship is shifted to starboard by, let's say, 200 meters. In narrow waters, this is a huge risk. We have seen what happens in Baltimore accident when ships collide with infrastructure. So this is something that we need to look at. We have experiments and in shipwreck simulators, 95% of people do not perceive that they are under cyber attack. If they don't perceive, they won't take action. So we will need new capabilities. So we were looking at data. So my center collects all these eye tracking information, brainwave monitors to understand the situational awareness of the planes. So what needs to be understood is how humans work with systems, perceive information, interpret meaning, and process, prioritize, make decisions, and take action. So design must need to support every step of it. If we don't understand this process, we design ships like this. So here you see City of Rotterdam. which collided with the vessel, because as you see in this ship, you have a spherical mouthward, and if this ship doesn't have a nose, which means that you don't have a point where you can reference which direction you are going. So if you make a mistake and look from an off-centric window, you may have the illusion, relative motion, that you are going that direction. So if the designer designs and gives this type of user will eventually make a mistake because context drives the performance. And then it's designed corrected afterwards. So human factors is beyond human technical skills. We study how humans interact with people, systems, tools, equipment, and working environments. And the aim is to make systems safer, easier, and more efficient. And as I said, it is now beyond technical skills. Our soft skills, situation awareness, communication coordination is more important, becoming more important in the context than the others. So possible conditions that influence performance: unlabeled, similar-looking equipment, complex tasks with poorly written procedures, uncomfortable places to work. These are all exist in shipping, and they are impacting already on performance. So we need a different way. We need a human risk-informed design framework, which we developed in our center already. And we are trying to influence the designers to integrate human factors, create the data, and collaborate more. So we need, in order to do all those, we need data in the first place. Unfortunately, we don't have human factors data for designers. So when a ship designer wants to focus on a system, he or she cannot go and say, what past excellence happened with the CIS system? So I can understand, then I can fix the issues at design stage. We developed Shield taxonomy, which is now being used by EMSA, big passenger vessel companies. So it is becoming very popular. And we created the human factors iceberg. On top of the iceberg, we have easy to see, easy to name layer. So you can look at an accident, you can say that human made a mistake. If you stop the accident in investigation at that stage, you learn nothing from that. In order to understand what went wrong, you need to dive deep, understand the conditions that influence performance, design gaps, etc. that exist. So we created a database as part of European Union project, and now we have a data set where we can select certain ship type, certain operation, and try to feed that important information back to the system. And if you look at analysis, this is how it looks. So you have your accident, failed barriers, and you have previous acts and specific conditions. They are all connected. So if one link, we can see how the accident developed and what is done to prevent it. We also developed risk models, human example risk models for similar to operate. Right? Not only what happened, but also how to which process today. So if I am going to put safety measures, for example, put that safety measure in the most common development. European also keep out that somebody and that plus performance. Let us spend our biggest present for our speaker, applause again. Yeah. To Dr. Jainal Arifin, Professor Mira. Now we will have take time or question time. Yeah. I will give for Q&A section. I will
give to the floor first. You have any, not if, but you need to get start with. So please, audience, raise your hand and please say your name in speech. Well, what the title, please, that by the
First of all, thanks for the insightful speech. My name is Vijay dari I'm a PhD researcher from Hospital Center. I would like to motivation from the goals and can see the profile advice that you have like very nice addition for because our source is from global site. So I wonder like if Dell and Bill have such strategy renewable for charging. We have like I can see that we have brand maps for charging in any India and then plans for different charging. Then still come from the global site. So I wonder like yeah, you mentioned about by and finding about ethanol and ethanol. Biofuel that by biofuel and palm oil and environmental. I wonder like that when from other we have a lot of problems in structure and palm oil and for Rokura, I really appreciate your speech that you mentioned about the kind of talk about the question is yeah,
Right. So I will let another question. So we can take up the question. Oh, okay. Or I don't. I think our why, but uh, what not, but not can bring more by now. So that we did that. One. So that the first the yeah. Okay, thank you.
right now the like our head of what is the why we want to spend so much on fuel that suffering our financial of government cost and oil fuel what what and first for the by your how the government have some plan how to yeah. Actually, it is also problem for us and for topic one topic. Problem of buying what and use availability of but the problem in transportation of the region. That's the problem we have. So the biome has for our region very low. The this for the power, but for the only for the region of biofuel for our only like Nobel and for the say use the B forty for all diesel. So if I work, I but the problem is also and difficulty for topic what the value. Sorry, yeah. So we had to from Mira. Then can you the current the three on that 10% of the basic vehicle power 10 of vehicle moving on coal. What happened to Jakarta? So instead of 6% of using coal in Jakarta, how about 6% using bio? that example. Okay? As I propose, can continue electrification, but at the small scale at the specific places where the grid can be produced using renewable energy. That's my proposal. And other other passenger car, since Indonesia already have B40, and in the picture maybe here B50, I propose passenger car should be the small diesel vehicles should be promoted. That's my opinion. Oh, okay. The second question from Professor. You can continue. On my the device. I don't have enough time during the presentation, so I just give the presentation. The device known as RS can produce emulsion fuel without emission of anything. Surfactant. Device itself needs to be installed into the engine near to injector. The emulsion fuel that produced is not stable. It's only stable only for a few seconds, 35 seconds. But once we produce the emulsion fuel, we directly injected that into the engine before it separated. So we produce the emulsion fuel based on engine demand. Okay, that's the basic idea of that. That is an answer. That's it. Thank you for your time. I believe that so many methods to check the other type of fuel. I also previously worked on the same field, so I think the water based check the so that's very interesting. Hope maybe in the next we can some can combine both for another so that's I think the question from your colleagues. Yeah, you did good question. Thank you very much. And yes, shipping is going to obviously shipping become the same thing that other sectors are. There has been a lot of research on this. So even now where hydrogen. There is been various implementation in the vessel, the ammonia, methanol, their own like they one is the outside. And there are some vessels which very low, for example, living with family, possibly. So they for there are a lot of things happening, but I think don't know which option will get. And there are risks that come together with sequence. So we didn't get enough time to plan this stuff. So there has been a target, and everyone is trying to reach that target by whatever possible. It's really bad, but I understand the fact. There is also
required for that. And you would see that based on that, your feedback, you would give my your certain place, but the other place will be up. But it's a range operation. What about that possible? So now, version normal version develop. So in the process of the organizing classroom, all experts, I think coming from academia or wherever, very multi-disciplinary. So that first actually I on the conversion. But they are thank you, Dr.
Online. Okay. So we can go online, yeah, participants. Oh, direct. So first, how can we see? Like the what via analyze then that down the British of the selection diamond of the very common that Okay, thank you, Dr. Gatot. Thank you, ya, Pak Arif Rahman. Hope the answering the question. The ladies and gentlemen, I believe that all of you have curiosity, yeah, to ask the speaker to the EVA time. So just give applause again to the all speaker. Thank you, Dr. K from Wira and also Dr. Zainal. Ladies and gentlemen, as we bring attention to those items struck by the powerful spirit of the yes, we have just heard. We began with Dr. Zainal Arif with the macro vision. We are emphasizing how national energy strategy is the bedrock for lesson transformation. Prof. Wira then challenged us with the practical realities and choice for the decarbonizing ideas growth and not fully electric, but use rather fuel, right? And also finally, Dr. Scott expanded our horizon to the global scene, reminding us that resilience must be the universal cause almost of transport. Together, they have given us a multidimensional framework. Resilience is not a single theory, but a systematic principle. So it is built on of global ambition and local solution, global ambition, local solution, and land-based. And even us not just a challenge, but a solution.
on behalf of the moderator for the session, thank you. Sorry for the mistake. I beg the session to the end. Thank you so much. Yeah. Another warm round of applause for our speakers and moderators. Dr. Aam, Dr. Tentang, Dr. Mira, and Ahmed, please remain on the chat because we have different opportunities that we have our speakers and the developer.
Okay, and speakers and moderator, can you please move forward in front of the table so that we can deliver the humble souvenirs that we prepared. All the speakers in front of the table. Just be careful. Hold on. All right. Okay, please give applause to Dr. Kurt. And let's have photo.
Now, what custom ceramic plate made by Aplication. Plate itself depicts wayang figures, a traditional puppet from Central Java and Jakarta. And we hope
Moderator, please give applause also to Dr. Aam. One more time. Beautiful. All right, thank you so much. So as Didi mentioned that the souvenirs is a drawing of traditional Indonesian puppet. Very beautiful drawing over there, I think. I hope that these souvenirs will be very good memories for you about this.
yes, it's a time for something. Take and the bridge are available for you all in the hall. Let's remember, it's home. Now, and the president provided in the hall.
Once again, please give applause to all of us for the amazing session. Good morning. And then, as Didi mentioned, we will have 10 minutes break. And please return here to start the next session at 10:28. 10:28. Thank you very much.
Halo, tes dulu. 1, 2, 3. Tes.
Tes, 1, 2, 3. Masuk. Bagus. Ulang.
Tes.
Tes. Oke. Tes. Tes. Oke. Cek. 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 Suara-suara. Ya, ya. Cek. Kita pakai masuk. Cek. Oke. Sekarang sekarang oh, pilih cil. Kalau di kita gigi kedengeran nggak ya? Cek. Cek. Panjang ya. Kalau panjang kayak begini kedengeran nggak? Bagus. Aman. Nggak ada masalah nih ya. Suara saya ada noise gitu. Kalau di sini kedengar stabil.
Nggak stabil. Tes kalau yang ini yang coba kedengaran tuh bagus, nggak ada masalah nih ya. Tes, bagus suaranya. Mau dicoba ngomong biasa kayak gini ya? Gimana kalau ngomong kayak gini? Aman? Kalau yang ini gimana? Bagus nggak? Orangnya bagus juga lah ya. Oke. Yang paling bagus di antara dua ini, ini nomor satu, ini nomor dua. Kira-kira yang mana? Yang nomor satu. Oh ini saya nomor tiga bagus nggak? Halo, apakah nomor tiga bagus? Nomor dua ya. Terakhir yang nomor empat nih, nomor empat, nah bagus nggak? Jelek. Tapi orangnya nggak jelek kan? Turun ya, turun ya. Tapi orangnya nggak naik turun kan?
Ladies and gentlemen, our next agenda is about to be. We would like to invite all participants of ICCEA 2026 to enter the main room so that we can get prepared for the next session. Thank you very much. Ladies and gentlemen, if you still have some snacks or coffee or tea with you, you can carry them with you into this room and continue to enjoy them while enjoying the next session. Once again, we would like to invite all the participants of ICCEA 2026 to enter the main room of ICCEA 2026. If you still have snacks or coffee or tea, you can bring them with you here and continue enjoying them while enjoying also the next session. Thank you very much. Once again, ladies and gentlemen, participants of ICCEA 2026, we would like to invite all of you to come back to the main room. And you can carry your snacks, tea or coffee with you here and keep enjoying them while also joining the next session. Okay. All right, ladies and gentlemen, welcome back. I hope that you enjoyed the coffee and snacks and tea over there. How was it? How was your coffee break? Tsunami-san, was it all right? Which snack that you like the most? Wait, did you enjoy some snacks? Okay. Not yet, because you are preparing for this session, I know.
Understandable.
Pak Hans, Dr. Hans, have you enjoyed some coffee and snacks already? Oh, Dr. Hans will be the moderator, but he already enjoyed some snacks. Well, how about other participants? Did you enjoy the coffee and tea? And I know some of you also have chit chat. Some of them are still having some chatting outside. That's okay. And I believe that some of you also make some new acquaintance or hopefully can collaborate. All right, shall we start? Okay, I would like to check if you're ready for the next session by asking you to give a round of applause for next session. Okay, it seems that we still need more coffee, I think. Maybe one more time. Okay, please give the warmest applause for all of us. All right, great. Okay, now we continue with our next session, and where we will discuss clean energy, led by our moderator, the head of Research Center for Process Technology BRIN, Dr. Hans Saputra. Dr. Hans, please come to the stage. Okay, and we will have two speakers, with the first keynote speaker from Imperial College London, UK, Dr. Dani Pujianto, and he is joining us online. I would like to check first if he is ready with us and can hear us clearly. Dr. Dani, can you hear us?
Yes, good morning, everyone. I can hear you clearly, yes.
Okay, can you say more, because we still need to check, fix our audio setting here in this room. So you can hear us clearly, Dr. Dani?
Yes, I do.
Maybe you need
That's
to
correctly.
volume up for this room.
Can you hear me? Can you hear me?
Or maybe, Dr. Dani, can you be closer to the microphone?
It's okay. Can you hear me?
We want to hear you more clearly.
Can you hear me?
Can you speak louder or maybe closer to the microphone?
I already tried to speak louder.
I know.
Can you can you hear me?
Yeah,
Can you
okay,
hear me
this
now?
one is much
Okay.
better. I
All
need
right,
to ask,
okay.
what time is it at your place right now, Dr. Dani?
It's 3:30 in the morning.
Wow, amazing. Please give an applause to Dr. Dani. 3:30 in the morning. Then
So
maybe after this session, you have to be ready for your work today, right? Well, I hope you have enough rest and then you'll have energy to start work.
Thank you.
All right, and also have our next keynote speaker, Dr. Kiyotaka Tsunemi from AI Japan. Please come to the stage. Okay. As a reminder, Dr. Head, kindly ensure each presentation to a maximum of, and to optimize our time, the Q&A will be conducted at the end of the session. But let me confirm to Dr. Dani. Dr. Dani, is it okay if we have the Q&A all together at the end?
I think that's all right. Yes.
All right. Okay. All right. So we will have the Q&A session at the end of our presentation. So please, we would like to ask for your cooperation. All right. ICEEA participants, let's give the warm applause to all of them for this session. Dr. Hans, the stage is yours.
Okay, thank you very much. Good morning, the previous guests, respected speaker, ladies and gentlemen. My name is Hensa Putra, head of the Center for Content. Talk about it. Very like want to invite the first Dr. Dani Sujanto. The hydrogens for apply for widely. Yeah. Therefore, no.
All right.
Hello, Dr. Dani.
All right. Okay. Good morning.
Dr. Dani,
Yeah,
can you hear Dr. Hans' voice?
I'm struggling to hear.
Your
But okay.
video is right
But
now. We cannot hear you.
okay. Can you hear me? Okay.
Once, okay. Dr. Dani, can you hear us?
I can hear you now. Yes. All right. Okay. Okay. Let me
Okay,
start.
no, okay.
Okay. Let me.
Karena posisinya posisi mic-nya lebih jauh daripada di tempat MC dan tempat mixer.
All right. Okay. Let me check.
Kecil suaranya.
All right. Can you see my slide? Can you see my slide?
Yes.
All right. Okay. All right. Thank you. Thank you, Mr. Chairman, for the kind introductions. Good morning, everyone. It's a pleasure to be here. Thank you for having me. Today, I would like to talk about, to share a study that we carried out at Imperial College London with with the collaboration with HIEC, is a research center which I will talk a bit later on. My talk here this morning is about the system benefits and the cost of the hydrogen integration to the electricity system. So before I start my presentations, I would like to talk a little bit about the hydrogen integration for accelerated energy transition, or we call it HIEC. It is a national research hub led by Professor Sarah Walker from the University of Birmingham. And it's funded by the UK Engineering and Physical Science Research Council, EPRSRC. 10 million over 5 years, started in 2023 and it will end in 2028. The mission is to provide the evidence base and also the modeling tool to understand how to integrate the hydrogen into the UK whole energy system in order to support the 2050 net zero goals. So I got a little bit of a short video here. I hope that you can, I hope it works. Let me try to see. All right. Okay. So please visit the website if you would like to know more about the HIEC. So I would like to start my presentations with a bit of introduction here that I think we do all agree that there are two main energy factors that we would like to use to decarbonize our energy system. One is, of course, is low carbon electricity from the solar PV, wind, other renewables forms, and also the low carbon generation like nuclear and so on. But also the other factor is green gases, and primarily is hydrogen. However, the traditional approach at this moment is that the electricity and the gas system, they are planned and operated separately. It's a loosely coupled. But there are emerging technologies such as the electrolyzer or power to gas or power to hydrogen, and also the other technologies like the hydrogen-based power generation or the hydrogen fuel cells that actually can link these two factors, energy factors, together. So the study that I would like to present here is aim to understand the benefits and the cost of integrating this, the planning of this and the operation of these two energy factors using the future 2050, the Great Britain's energy systems. In order to do that, we use our integrated whole energy system modeling. It is a very complex modeling that look into from the supply side until to the demand side. The idea is try to understand what are the capacities for all technologies that being involved in the energy systems and also how it's operated. and then evaluate the cost performance of different scenarios. It is a very large scale optimization problems. And the output of this optimization problem is that we will understand all the energy infrastructure capacities required. So this is the key results of the study. So we have two cases. One is the silo approach. So the silo approach is based on the current traditional approach where the hydrogen systems and the electricity system are planned or operated separately. And the other one is that if you use the integrated approach. So if you can see in the left diagram there, in the silo approach, when we have the hydrogen demand, that the model will propose the use of the autothermal reformers with the CCS and also the biomass gasification with the CCS in order to produce the hydrogen. So the blue hydrogen and kind of like a light blue hydrogen from the biomass. And the reason why there is no electrolyzers there is that the electrolyzers cost, the hydrogen production cost for electrolyzer is much higher compared with the production cost from the blue hydrogen, as you can see on the right diagram. So the cost of the green hydrogen production is around maybe $3 to $6 US per kilograms, while for the blue hydrogen it's almost like half. So from the economic point of view, then it is not economically feasible to use the green hydrogen for the electrolyzers to produce the hydrogen, because it is less cost efficient compared with the blue hydrogen. However, when we do the integrated approach, the model then proposes a certain amount of the green hydrogen to be produced. So we can conclude that this integration is actually enable this economic feasibility of the electrolyzers, although the cost is higher, but the electrolyzers provide some flexibility to the electricity system, which is critical, especially in the system with the higher renewables. And we can also conclude that the optimal portfolio of the hydrogen production technology should involve different technologies. So each technology has different roles. For example, with the electrolyzers, it provides flexibility, and for the autothermal reformer and the CCS, it also provides the firm and controllable capacity, while for the biomass gasification with the CCS, it provides negative emission technologies, which is important to offset the carbon emissions. Now, the impact on the electricity demand, as we can see on the left diagram, we can see that in the integrated approach, we will require the demand is higher compared with in the silo approach, and this is driven by the increased electricity demand from the electrolyzers. However, it doesn't trigger the peak if we can optimize the electrolyzers properly. On the right diagram, we see how the electricity productions actually change. So in the silo approach, we can see that there are some amount of the gas CCS to be used in the system, while when we go to the integrated approach, a significant more renewable can be integrated in the system, and then there is a shift between the use of the gas CCS into the hydrogen generation. Okay. So the result indicate that by having integrated approach, integrating these electrolyzers to the system, we can actually connect more offshore wind in the GV system. Now this is the benefit. So the model outputs consists of the capacity of all the energy infrastructures, and then also the operation cost. So then by comparing or by calculating the difference between the costs in the counterfactual scenario, which is the silo approach, compared with the integrated approach, we can then identify where the costs and the benefits of this integration. So if you look at the left diagram here, above the zero is actually the additional costs in the systems that need to be there. And we can see that with the integrated approach, we will require more cost in the low carbon generation and also the generation of non-low carbon generations. There is a little bit more expenditure in the transmission system, but of course the cost of the electrolyzer itself. Well, the benefit is that there are a lot of savings in the operating costs of the electricity, and this is primarily due to the shift between from the gas CCS to the hydrogen generation. There is also significant reductions in the cost of negative emission technologies from the direct air carbon capture and storage, and this technology is actually used to offset the carbon emission there. Some saving in the carbon storage, and this is primarily due to the less use of the gas to produce the electricity, and also the saving in the use of the gas to produce the hydrogen by the use of the autothermal reformers, and some increase a little bit in the electricity export. So the overall savings is can be like a 6 billion. We calculated it's around 6 billion pound per year, and that is a very significant saving if we integrate the planning and operation of these two energy factors. Now this is showing how these technologies play a role during one week of the critical sort of like a period during the winter. So you can see that on the day 6, so the upper diagram shows the power generations, while the lower diagram shows the electricity load. So we can see that on the day 16 to 18, there were very little output of a wind, and this is in a scenario we made that this day 16 to 18 is the coldest were the coldest day during that period. So the demand is relatively high. So when there were no wind, you can see that there are some the role of the gas CCS, but also the role of the hydrogen generation play a role here, while also the system is importing power from the neighborhood country. But then when on days 19 to 21, when the wind actually increased significantly, then there is a role of the electrolyzers for balancing the systems during the high wind output. So these two technologies, the hydrogen technologies, play complementary role in balancing the system. And that is also that during for the system planning, we also need to take into account the hydrogen storage. Then when we introduce the electrolyzer into the systems, this may increase the need for the hydrogen storage that have to be provided. And then our study shows that most of the hydrogen storage will be from the underground large-scale underground hydrogen storage, which indicate the need for the long-term storage in the system. Of course, this has to be worked together with other energy storage like the batteries and so on, which can provide the short-term balancing. And the planning of the hydrogen technologies also need to take into account. For example, like in here, the model can also indicate where the optimal locations of the electrolyzers. And if you see that there are two scenarios that we investigated here. One is with the low flex, and the higher flex that is associated with the flexibility provided by the demand and also the distributed the storage. But as you the result shows that most of the electrolyzers are in the place where the wind are very strong. For example, like in the north of the GB system, in the Scotland part, and also in the southwest of England, at the bottom there. And we also need to take into account consideration into the water constraints, where because with the water electrolysis, because there's already some water stress, especially in the England part and especially south of England. But this may be a less critical issue because we can put electrolyzers near the sea, and then we can use the seawater using the desalination, which will increase the cost, but it is a slightly increase. Another thing that we have done is to carry out a large number of sensitivity studies looking into different conditions that we would like to understand the drivers of the optimal capacity of certain technologies. For example, in this case, is the electrolyzers. So we evaluate a number of different scenarios. One is that, then here we identify that the need for the electrolyzer is driven by, first is the decarbonization of heat by using the hydrogen heating, for example, that will increase the hydrogen demand. But also if the natural gas price increase significantly. So if the natural gas price increase significantly, then the electrolyzer, the hydrogen production cost from the electrolyzers becomes more competitive compared with the hydrogen productions from gas. So and of course the other key drivers also include that if the electrolyzer cost can be reduced, or also the cost of the renewable sources like wind and so on becomes less. Another important driver is also depending on what kind of other flexibility technologies that will present in the system. So if it is a low participation from demand customers, for example, or in the lack of investment in other flexibility like battery energy storage systems, then of course the flexibility from the hydrogen technologies becomes critical, and this will drive the need for it. I think I would like to close my presentations with the conclusion here that the optimal integration between hydrogen and electricity system brings substantial benefit, and that's the reason that in the UK we have moved from previously the system operator and for the electricity and gas, they were separated, but now we have moved into a unified national energy system operator, NESO. And so this integration will reduce the system costs, as we have demonstrated. It also will enable more connection of renewable and low carbon technologies. It can utilize because both energy factors, hydrogen and electricity system, can maximize their synergy through this utilizing the sector coupling flexibility. It will result in the less carbon footprints, and also the need for the negative emission technologies and carbon storage, and also less use of the fossil fuels. But however, the integration will require careful planning and selecting the optimal portfolio of technologies. It will require the supporting infrastructures like this, the transmission, hydrogen storage, and so on. And it also need the optimal operation coordination between the two. So the operational of the system becomes more complex. It has to be that the value of that, and it has to be also should be reflected into the market and commercial framework framework that should be designed in order to facilitate and incentivize the deployment of such technology. And this has to, of course, has to be supported by the appropriate regulations. I think that's all my presentation today. Thank you for listening.
Thank you very much. Thank you for hydrogen. Okay. So first, I'd like to talk about what next. I'd like to frame up the of hydrogen. Third, I'd like to and finally, I also show you about public upstream. For what is for what are about? So this table shows activity of one medium list of this. Example, only 1.4 or cancer were hard to do. 1 hour and 4 miles or random. Traveling 300 miles by car, traveling 10 miles by bicycle, and flying 10,000 miles, 1,000 miles by air. Have the same level of another example of able of that shows the of the first of access that so when the for high, the right upper zone, for example, annual with it's under zone of zone. So what side The bottom. Double. Service other other management space or other what there is raising concerns about but without of and so to address this issue of how you how different by asking how they done. So it's the assessment that must be written about. So how to consider study by multiplying probability by years what possible. This figure shows the loss probability. So the probability appears also high at now, but when the probability low or severity low, reduce figure. And at the middle zone, it should be constant. Selectivity. So, next, like about hydrogen. And this figure shows strength. Here's the bond and the hydrogen between constructed then. So number of FCV on has been increasing for 10 and hydrogen refueling station like this also so the figure is the location of the and so as of February 2024 and offsite system 100 number and there are number 31 on site and but 30 mobile station. So and so about 100 and 170 station line. So and the locations Tokyo area, Nagoya area, Osaka area, and the Takushi area. There are many. So the hydrogen should be regulated. So in Japan, there is a law, the name is the high pressure gas safety distance between public road and dispenser is above 8 feet. And safety distance between site boundary and component safety also is above 8 feet. This allows shorter safety distance by placing barriers. So the height of barriers usually is approximately 5 feet. Please remember this 8 meters. So why this stuff? Why is it necessary for hydrogen station? For administration, the technical standards under the law were established concerning the management of the other. Typically, the imperative will absolutely oppose human ideology. So the separation, consider that the separation distances are defined based on the scenario of a deep goal of 0.2 meter or 1.0 meter diameter forming the height. But we consider that it does not account for other scenarios, such as like that. And for operators compliant with the technical standards of the law, it goes extremely high cost for hydrogen vehicles. We wish to promote the widespread adoption of hydrogen stations by reviewing the current regulatory framework. They offer and for speakers, current era no longer set the nation base. So for social acceptance, it is necessary to evaluate by comparing it to a acceptable level. So we set framework of risk assessment. This figure is the framework of advanced risk assessment. Risk is calculated by 100%. So we estimate emission through the scenario of using the hydrogen. And next, we identify the hazard of maximum pressure involved in those and atmospheric concentration of it. And next, we use probing function to human body of Earth by so we calculate the concept or probability of the damage. The spread probability, we estimate probability of 5 types, right? And finally, there is between ozone, radiation, and activity. So, to consider this spectrum criteria, the here is the base study spectrum criteria. If the annual risk below 10 to the minus 6, it is more than acceptable. And if the annual risk is over 10 to the minus third or 10 to the minus fourth, forever. So ISO set the spectrum criteria as the right thing. So for example, facility users and the process annual individual risk is below 10 to the minus fourth. And for vulnerable populations, annual individual risk below 10 to the minus. So we use this acceptance criteria by ISO to use all this stuff. So I would like to show you this process. So the traffic for organic hydrogen. And we considered 21 types of scenarios of so 3 sections. I'd like to show you if you have pronunciation for so we conducted 2 types of assessment. One is screen risk assessment, calculating the largest hazards for all the action scenarios. And next for quantitative risk assessment was conducted for the action scenarios by types. And this is the result of the study.
So this figure shows the maximum individual for here, and we identified some scenarios at a high level. Okay. So this is the result of quantitative capacity. Show you the distribution of individual model. And scenario 1, scenario 2, and protection fire. So the current regulation safety for the safety of the public. So I also conducted public the research questions are how people perceive how many acceptance which were introduced, right? Does this or safety measure information change before acceptance from the direct? And what factors then acceptance from the direct? So we conducted this survey to analyze the relation between the presence of HRS risk and safety measure information. So after we showed explain about HRS, we also provided information on this one safety measure. 3 types of information. So risk value and risk value plus difference and safety measures. We divided respondents according to the combination of these 3 types of information. And this is the result of public acceptance survey. This figure shows that when the risk information provided, the red and known factors are going low. So the risk information might alleviate respondent feeling on it. And the right figure shows that the risk information anything is acceptability under the assumption that HRS was built to their home. And this provision of risk information to neighbors would facilitate better understanding of the. And these are the beginning topics. And that's all. Thank you for that.
Thank you very much, Dr. Fernandi. And
I haven't seen questions in the chat Zoom already. Oh, okay, we have one in YouTube. However, I need to make sure again if our participants in Zoom can hear us, because there are some notification that they cannot really hear us clearly. So let us check, because, yeah, especially for Dr. Danny. Dr. Danny, can you hear us now?
Yes, I can hear you, and I can see the questions there.
All right. Well, let's
Yeah. All right. So, the question is about how can integrated electricity hydrogen system reduce total system costs while improving flexibility, reliability, and emissions outcome compared with silo-based approaches. So, with in the system with a lot of renewables, flexibility is a critical component, because the variable renewables, they are not flexible, and also other low carbon generations like nuclear, they are actually inflexible generations. So the flexibility the flexibility is coming from in the future will come from demand participations and also the battery energy storage, for example. While with the hydrogen system integrated to the electricity system, then they have the electrolyzers, for example, which can provide some balancing. So when the system experience high renewable outputs, then the electrolyzer act as a load, as shown on one of my slides. While when there is no wind or low renewable output, then the hydrogen generations, either it is hydrogen CCGT or the fuel cell, can generate. And then the hydrogen system also have very big hydrogen storage. So in that context, it can store the energy and then use it for the production of electricity when it is needed. And if we couple these two, then this can benefit both systems, and especially particularly the electricity systems that require the flexibility. So it improves not only the flexibility, but also the security and or reliability, but also reduce the emissions as shown on the slide, that in the silo approach, when we do not have this hydrogen generation, for example, then we will rely on the generation like gas with the CCS. That of course we need to capture that the carbon in order to reduce emissions there. So that's the reason why the integration between these two energy factors are very critical to reduce the system costs. I hope that answered the question.
Okay, thank you very much. Yeah, you think? Back to thank you.
Okay. Is there any example of incident related to HRS, Japan, explosion or something like that? And if there is, what is the main cause? Main cause. But I currently take more care on that maybe risk. Fine. Thank you for your question. And in the presentation, I'd like to switch to the history of HRS. But in Japan, there are some levels of upstream hydrogen liquefaction. But there is not so so we estimated probability for severe using not only Japanese data and or hydrogen liquid data of hydrogen, but also we use US and Japan's hydrogen using facility for the main host uh, okay. So there's them. Of course, the dispenser and the surrounding area is one of the most opening places, but also some accumulating or area, high pressure area. There is a people hydrogen. Thank you very much. I think it's very important to think about the question. So hydrogen refilling station has high pressure of hydrogen. So it is the most high level. It has the most high level risk, and also it takes much cost for construction. So so we should consider the high cost of hydrogen refilling station. So we also should consider to set appropriate goal for regulation, not too strict, appropriate regulation. But that is the kind or for Dr. Dani, is there any commission in UK or Europe which you can commission for us for the safety or about the patient?
My apologies, but I couldn't hear it properly. So if somebody can help me with the typing the questions on the chat box, that I will appreciate that.
Maybe about the connection. I did the problem with connection to our room. You hear my voice now?
I can hear it, but it is breaking a lot, so I couldn't understand the question. Sorry.
Okay. Thank you very much. I think now we're still facing the problem with the connections, but we can make the communications by email or others. And as we come to the end of the sessions, I would like to express my sincere appreciation for our speakers for their insightful presentation and valuable contribution for us. And I also like to talk to thank for all the funds for the. And we hope that will inspire the future collaboration. On behalf of the moderator and the of committee, I'd like to apologize if there is or thank you. Very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Once again, please give biggest applause for this session. to our moderator, Dr. Hans Saputra, and to Dr. Dani, and also to Dr. Sunemi for your valuable contribution to this session. Once again, maybe let's give a biggest round of applause to this session. And Dr. Dani, we again apologize for the technical issue. Hopefully we can improve next time. Thank you again for joining with us. And we would like to deliver humble souvenir as a symbol of our gratitude to our speakers. However, since Dr. Dani is not here, well, I can go to UK happily to deliver. If the committee send me there to send the souvenir, well, because I cannot for now, so we can only show you the certificate, digital certificate. Please give applause once again to Dr. Dani.
All right, thank you very much.
Yes, Pak. Thank you so much, Pak Dani. All right, so next, for the speakers and moderator, we would like to deliver our symbol of gratitude. Thus, we would like to invite Dr. Aam as the head of Research Center for Transportation Technology BRIN to deliver the souvenirs to the speaker and moderator. Speaker and moderator, could you please move in front of the table? Yes. Okay, first to Dr. Tsunemi, who come all the way from Japan, from AIST Japan. AIST Japan and BRIN have a very long collaboration history. So we are very grateful for the continuous collaboration with AIST Japan. Thank you so much, Dr. Tsunemi. And next, I would like to also thank to the moderator, which is a very good colleague of Dr. Hans, Dr. Aam, Dr. Hans. Thank you so much. Maybe group photo together. Can we still show Dr. Dani again, if he is still joining us? Okay, so we will have group photo together, including Dr. Dani from UK. Let's have group photo. Please give your best smile. 3, 2, 1, cheese. One more time. 3, 2, 1. Okay. 3, 2, 1, cheese. All right. Okay, thank you very much. Once again, ladies and gentlemen, please give the warmest applause to this session.
Now, ladies and gentlemen, we're going to continue with our first industrial and ministerial session. In this session, we will discuss the current policy and industry landscape led by our moderator, the head of Research Center for New Technology, Dr. Yan Setiawan. I'm taking invite Dr. Yan to the stage. Now, we're gonna continue the session. The first speaker is Mr. Budi Rahman, head of the Green Project Development from PT Tripata and Construction. And the second speaker is Mr. Hendro Gunawan. And we have our Dr. Batia from the Industrial Working Group for Battery Electric Vehicle, Ministry of Industry, Public of. So I'm going to take online for Dr. Hendro Gunawan. Are you there, Mr. Hendro?
Yes, can you hear my voice?
Hendro?
Yes, can you hear my voice? Hello? I cannot hear your voice clearly, but can you hear my voice? Okay, maybe I will use headset. Okay, wait a minute.
Welcome. As a reminder, the moderator, Pak Yan, Mr. Yan, Dr. Yan, you can ensure please for the maximum 10 minutes. So it's a little bit different than 10 minutes per speakers, and the Q&A will be conducted at the end of the session. Right, for your preparation. Next,
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to Industrial Talk 1. It's an honor to have this distinguished audience here with us, Mr. Sinawan. I'm from the Research Center of Field Technology. Today, in this session, as an Indonesian sustainable landscape, we study the government policy and the culture and engineering expression has never been more detailed. Three speakers from two speakers from the ministry and one from the ministry. We can start from the one or take what is your happy to be here, presenting industry company. So my name is Wiramawan, and I would like to share our view, our experience, our ongoing development of sustainable aviation fuel from our perspective. So a bit of Tripatra. Want to use Tripatra been years in Indonesia, working on engineering, management, and projects across all the sectors. So I think we service to our client across the whole project life cycle. I think for planning, development, and also for the and now. I think I also would like to introduce that we have recently, 2 years ago, a Green Energy Development Business Unit. So I'm part of this new business unit. And basically our focus, our scope is on the investment, on the development of and also ownership of green energy infrastructures. And the sector focus that we are currently starting to do is in the sustainable aviation fuels, and the biomass, bioethanol, and also other chemicals from the waste base. So that's our focus. I think this is basically to balance our portfolio of the Patra or as a service company, to also become a developer of global asset. Okay. So this is our focus. Basically, currently we are doing on mainly based from found-based waste. Several routes that we are looking for. However, the one that currently quite clear in our organization is the development of the sustainable aviation fuel. This is something that I would like to more focus on sharing these matters. And while the whole basic sector that we are aiming is basically the waste sector, so hopefully also can for the target. So the way we are looking as industry, the first time is of course with the global needs. I think the aviation decarbonization is one of the focus that we are looking, that we know. I think the aviation, one of the biggest contributor is the fuel, and then SAF is 70%
of the availability of staff. The demand itself is rapidly growing, driven by the mandates from the Bureau, from the other countries that are start to implement the staff implementation. However, also the feedstock is one of the challenges to fulfill the demand of the staff. But looking inside Indonesia, yes, industry also looking at this. Indonesia actually have quite a potential feedstock, a couple of technology roads participate, utilize feedstock of Indonesia for the market. So this is a bit of overview of the market itself. I think because of the mandates, but 2030, I think the demand is quite high, 18.7 billion ton per annum. However, from the projected project that will be built according to the four gap, that the opportunity, also the challenges, and also zoom in into Asia Pacific. I think the gap itself is around 1.2 million ton per annum. It's still quite huge to provide. That's the challenges came also because of the feedstock limitation, but also I think a couple of development is today because of economics, because of the source of the feedstock, and so on. So that's, I think, what happened in the market. And looking into the couple of pathway to the technology, the HEPA is the most major one. This is something that we are focused currently for HEPA. The technology is already there. It's already commercialized properly. The cost also now is more and more also competitive, but the emission is still quite high, but the stock has become more challenging. And the rest of the roads like alcohol jet, acidification, and also power to liquids, some countries started to develop a pilot plant. However, still it's competitiveness of the cost is still high, and then still need time for major for supplying that. So and then back to Indonesia. I think Indonesia, if you look to overall potential feedstock and also the overall routes of technology for SAF production, I think we have potential up to 80 million ton per annum. I think it's incredible for Indonesia to start from HEPA, get a lot of potential for us to produce the SAF. It's not taking into account also the power to liquid, which is also from hydrogen and CO2, not calculated here, but I think based on the waste feedstock itself, we have a lot of SAF by worldwide. So if you look here, this is the type of feedstock that we are currently focusing, like palm oil and oil. It's already eligible worldwide. There is a lot of potential, but quite limited source. PFAD came from the waste of also the refinery. Technically can be used for HEPA technology process. However, still have a challenge on the acceptability for still not eligible. And the rest of the screen also, I think we have a couple of stuff. It's ready, however, technology is not ready for like in the last year. So this is the couple of hurdles or challenges to look into the HEPA technology. Our perspective is the pre-treatment technology, because I think the content, because it comes to the waste, the FFI, and metal, and the other residues content, this is important. The pre-treatment also needs to design accordingly in order to have a more effective production of stuff. And also the traceability is important, where the waste came from, and how we track it, how it's certified, because the global market requires this really traceable. And also if you look in the other side of the business, want to have it finance and also like investment, it's also to be bankable, be able to traceable the and the acceptance of the national requirements also important on this one. And I think one of the achievement last year, we also supported together with boss,
transportation also have been able to also promote palm oil. We accepted on LCA venue. We proposed last year, accepted by the end of 2025. This is a real example of collaboration, industry and also academic and also government. So it's not and on the right side is the acceptability of the tool. The volume is there, but still not acceptable because it's still considered risk by the global perspective. Critical collecting also critical development of the palm industry now. Next. Just a bit overview. I will not touch details. So this is the challenge on the APG. I think our feedstock, I think potentially in Indonesia is like palm kernel, solar and all fountain. However, the specific energy development is important to ensure the effectiveness of the perfection of the feedstock, also the characterization of the product itself, and I think the pilot validation is important. Test the enzyme test. This is where the one is. And also this is for the DLT, couple of challenges. Just to know how we got it. And the challenge of the itself is the processing of the treatment. And this is what we are doing. Patra currently now is not only the technology and processing focus on the technical side, but also how we can also secure long-term supply contract with stock, collaboration with plantation on the collectors, and also the offtake is important. How the market will accept our products to have the stock and also process, and how also to attract investment and finance is also important. How to make it whole. And then the collaboration across these four sectors of government, having to also have a good roadmaps, and also how regulate better to support the investment and also development. The academia also, because of the future of technology also there, I think it's important to collaborate, look into how to commercialize the future technology, how to utilize more fixed stock in Indonesia and open just China. That's our last question.
Now to the second speaker, we have Mr. Patria from the Ministry of Industry. What is yours?
Good morning, distinguished guests, and honorable participant. I would like to introduce myself. My name is Patria Monando. I'm from the Ministry of Industry. Currently, I'm in working team as a head of working team of battery electric industry. Today, I would like to present about the automotive industry in Indonesia. Especially regarding the electric vehicle industry. And you know, one of our key factor to reduce emissions are bahasa, but I will try to explain by this. First, we see the profile for electric automotive industry as a whole, not only electric vehicle industry. We already have industry 41 industry in four-wheeler and also in two-wheeler 82 industry, and also you can see the production progress in 2024 and 2025 is decreasing a bit in four-wheeler, but in two-wheeler we have a stable condition. Right now it's about 6.9, almost 7 million units in a year. Next, for electric vehicle industry, right now we already have 13 industry for four-wheeler and 68 industry in electric motorcycle electric vehicle. Also for bus, electric bus, we already have 9 industry. In total investment about 25 trillion rupiah. Next. For market share, four-wheeler, we already know, maybe you already know that battery electric vehicle right now in 2025 has got highest percentage among the last year, 2024, still 5%, but right now it's almost 13%. And also the conventional vehicle right now are decreasing into 78%, the market share. Next. Yeah, we can see the key point that all of the technology, XEV, we call it XEV, for BEV, plug-in hybrid vehicle are growing from 0.36% in 2021 to become 21.8% in 2025. But BEV has a most growing number in 2024 to 2025. And also the hybrid is stable and become the backbone for the transition. And ICE, the conventional vehicle, are decreasing in the 5 year from 99% to around 78%. At the production, we can see the BEV that produced in Indonesia in 2025 are still about 2% because the most of the market share are from import, the CBU unit. But in 2026, there are some of that new industry in Indonesia, including UID and also Finpas and other brand that already ready to produce in Indonesia, and we optimize right now. In 2026, the total production for BEV are increasing based on the data, and also the market share are also increasing. Next. We can see right now the automotive value chain that this automotive industry are consist of a lot of people are joining inside the industry. We can see the manpower are about 1.5 million, and also the component industry from tier 1 until tier 3, and also for the motorcycle industry. This is including the electric motorcycle, that electric vehicle are around 25% based on this percentage for the total manpower. Next. This is the value chain for the EV battery in Indonesia. Right now, we are still not have the complete ecosystem, because in recycling, we are still have one industry, and also for the refinery, we are still looking for a new investment in anode and cathode material to produce. A lot of them already just using to import the battery cell and assembling the pack in becoming a battery. Next. This is the battery EV industry in Indonesia. We have already got the HLE Green Power, Hyundai Energy Indonesia for the battery pack industry, ABC Battery, and Gotion. Gotion is the main, the battery is for the China brand. It's supporting by the Gotion, and also the electric vehicle for motorcycle, we have Energi Selalu Baru. Next. In June 2025, the government already have numerous and several joint venture for the ecosystem of the electric vehicle, and we hope that this joint venture, 6 joint venture between Indonesia and also the China industry, we will have the whole ecosystem as a whole from the number 1 joint venture until the 6 is the recycle joint venture project. Next. This is the regulation for the electric vehicle program. As we already know, it's based from the Presidential Decree 55 2019 and also the 79 Presidential Decree 2023, and also we already have some supporting regulation to reach the Indonesia commitment in Paris Agreement to reduce the emission gas emission to 31.89%. Next. From Ministry of Industry, we already have the regulation for electric vehicle, not only electric vehicle, but also for a low carbon emission program. And also we already have the regulation for the specification, the local content calculation, and the roadmap for the electric vehicle. Next. This is the requirement for low carbon emission vehicle program. We already launched the regulation in 2021. The technology are consist of the LCGC vehicle and also the hybrid, plug-in hybrid, battery electric vehicle, fuel cell, but we still haven't the industry right now for fuel cell electric vehicle, and also the flexi engine vehicle. And also we already have the LCEV value chain that consists of the 15 participant program, and they have the lot of resources, not only in West Java, but also in Central Java and East Java, and Banten also. This is the total investment for LCEV program participant. There are 15 participants from Astra Daihatsu to Mitsubishi Motor, and the total investment is 22 trillion rupiah. Next. This is the production and the sales for the LCEV program. We can see they already reached the market share is about 30% until 40% for all total the automotive industry, market in Indonesia. Next. Okay, that's all for me. Maybe we can continue the discussion next. Thank you very much. Okay, Mr. Patria.
Excuse me, I would just like to confirm, yeah, are you still available to? Okay, shall we have Q&A directly to the first? Yeah, since Mr. Patria have a urgent agenda soon in next 15 minutes, so maybe we can have Q&A. Is it okay, all the speakers? Yeah, so maybe we can have Q&A directly to Mr. Patria only. Any questions? Any questions in online? Okay, but maybe you as moderator, we had something like to.
This is very interesting. So I want okay. Then there is a opportunity. Yeah.
Yeah, this year, 2026, we already have a new player coming to Indonesia by past that the same group as Indomobil, so National Assembler. A lot of brands are coming to Indonesia and produce in Japan. Right now, we are focused on how they can increase their production, and also they can reach the local content requirement, because Indonesia local content requirement for electric vehicle are 40% this year and will increasing to 60% next year, 2027. And the key to reach the local content percentage are the battery. So we also focus on how the battery industry in Indonesia can support the brand that already produced in Indonesia. As As example, I mentioned before, Goshen and also Hyundai LG Indonesia can support, and also UID as their information, and will also come with the battery industry from the China, CATL. They will build their factory in Indonesia.
How about the name TKDN? So maybe localization, how much will be regulated?
Yes, Pak. For TKDN or local content requirement, we already have the regulation in Minister of Industry Regulation number 6 2022 and 28 2023. We in that regulation we inform that they must reach the 40% minimum to enjoy the incentives from the government. And also in the next year, they also need to have the requirement to increase in 60% because we already also have the roadmap. And in 2030, the local content requirement will increase again to 80% in 2030.
Is there any question from the audience? Sure.
Okay, maybe if there is any later, because it is a sudden Q&A, yeah. Maybe some people are still preparing the questions. That's okay, maybe later we can contact Mr. Patia if you have more questions. Since it's already time for you to leave, but we would like to deliver our souvenir to you. Is it okay to have this session for now? Or special only for Mr.
Yeah,
Patia?
I apologize. Thank you very much for the opportunity.
Okay, we would like to invite Dr. Lutfi as a chairman of ICSEEA 2026 to come to the stage. Can you stay here, sir? And thank you very much, sir, for being with us despite your busy agenda today. Thank you so much, and please give applause to Mr. Patia for sharing a very inspirative presentation. Okay, we can resume.
Okay, we continue to the third speaker, Mr. Hendro Gunawan from June. The floor is yours, Mr. Hendro.
Okay, thank you, Mr. Jan Setiawan. Okay, Honorable
Mr. Hendro,
representative from,
this is your
yeah,
turn to present. Can you hear us?
yeah, I can hear you. Yeah.
Okay.
Okay, can you
perfect.
hear my voice? Okay,
Yes, you can start your presentation.
okay, thank you. Okay, thank you. Ladies and gentlemen, participant of the 13th International Conference on Sustainable Energy Engineering Applications 2026. Good afternoon to all of you. Let me introduce myself. My name is Hendro Gunawan. I'm coordinator for cooperation and investment in renewable energy in the Directorate General of New and Renewable Energy Conservation, MEMR Indonesia. I represent Ms. Ania, my Director General for NREEZ. She sends warm regards to all of you and apologies cannot attend this important conference in person. Honorable participants, next please. Presiden Prabowo, one of the 8 vision is promoting national self-sufficiency of food, energy, and waters. Based on our government regulations, number 40 of 2025 concerning the national energy policy, the energy sector has a target of 2060 with emission target of 129 million ton CO2 equivalents. And we have target for 70 under 22% renewable energy mix with a primary energy target in 2060 to achieve NZE. And energy sector emission peaking will be achieved in 2035. Next slide, please. Next slide. Indonesia also have commitment to achieve NDC, nationally determined contributions, including in the energy sectors. Since the issuance of the first NDC in 2016, we have updated NDC in 2021, and also we have enhanced NDC in 2020, and now we have second NDC in 2025. Second NDC has a different approach from the enhanced NDC. The first one, the energy sector's emission peak is projected to occur in 2035, while the national peak remain in 2030. And the second one, second NDC has been adjusted to government regulation number 40, 2025 on the national energy policy, where 8% economic growth has been integrated into the high scenario. If we see on the right side on the graph, we see that energy sector has high target around 358 million tons CO2 equivalent reductions. And since 2019, we always meet the target for CO2 reductions. Next slide, please. In roadmap of net zero emission 2060, if we focus on decarbonization of transportation sectors, we will see that since 2023, energy management is mandated for transportation sectors that consumes energy more than 4,000 ton oil equivalents. In this roadmap, we also promote electric vehicle for two-wheelers and four-wheelers. We also promote the use of hydrogen in transportation sectors, including truck, promoting ammonia for shipping, and surely biofuel for transportations. Next, please. In land transport, we implement sustainable biofuel mandatory programs. Since 2025, the B40 mandatory policy has been implemented nationwide, and comprehensive study for the implementation of B50 is currently being prepared. And we also have bioethanol programs that has resumed through the E5 market trial in 2023, and now we have planned to implement E10 in 2033. We also encourage the adoption of EV by providing incentive for electric vehicle production and sales, particularly in the two-wheelers and public transport segments, as well as the development of national electric vehicle infrastructures, including charging stations and battery manufacturing plants. We already have national hydrogen strategy and national hydrogen and ammonia roadmap outlined. Plans to integrate hydrogen into various transportation sectors, including heavy transport and public transportation. Government will implement also stricter regulations on fuel efficiency and emission standards to improve air quality. For maritime sectors, mandatory biofuel is applied for ships to ensure the use of renewable fuels in domestic shipping and operations. Government right now is also exploring the use of hybrid and electric ship as alternative for short-range coastal shipping and also small-sized vessels. For the aviation sectors, after the successful test flight in 2021, and the commercial test flight in 2023 using G2.4 fuels based in RBD PKO. Indonesia plans to implement G3 or 3% of sustainable aviation fuel in 2026-2027 at selected international airports. Indonesia actively developing and producing SAF by utilizing local resources, especially RBD, PKO, and used cooking oil. Additionally, development plan also include the use of non-standard coconuts and palm kernel expeller as alternative raw materials. As I mentioned before, we have obligation on energy management implementations in transportation sectors. This is stated in Government Regulation number 33, year 2023, for all of the sectors, from energy providers, including power plant, industrial sectors, building sectors, and government facilities, and including transportation sectors. So, transportation sector, including maybe taxis, flights, or maybe air flights that use energy more than 4,000 ton oil equivalent mandated to implement energy management. We also have pilot projects in energy management for transportation facility. We have cooperation with Ministry of Transportations. We have pilot projects in Igusti Ngurah Rai Airport. 2 years of implementation, energy management, they can saving more than 200 billion rupiah. And now we try to implement energy management for bus terminals and also for seaports. We right now also developing fuel economy standards, not implemented yet, but we are developing now in the developing stage. Economic growth and increased demand for freight transport will lead to millions of conventional trucks being sold before 2035. Without strong policies, the rate of efficiency improvement in the transportation sectors, especially logistics, is expected to be slow. Fuel economy standards provide a clear policy signal to curb fuel consumption, operational costs, and emission, while also supporting NZD 2060 and energy resilience. Next, please. And we also have a pilot project on how we utilize emission reduction monetizations. Last year, we have pilot project with 5 companies that already report the implementation of energy management. We help them to drafting DRAM, Daftar Rencana Aksi Mitigasi. This is one step to get emission reduction certificate that can be sold in the markets. And right now we have a technical assistant for preparation of mitigation action plan document, or Daftar Rencana Aksi Mitigasi. We give assistance for PT Transjakarta in preparing this DRAM as an effort to implement the economic value, to get economic value of carbon in the transportation sectors. Right now, the status already submitted to the Secretariat of SRN in Ministry of Environment for validation process. Next. Okay, thank you.
Thank you, Virendra. Give applause to our speaker. Okay, the last speaker maybe present. Is there a question from Zoom? So yes. Okay, that's one. Okay, please.
Yeah, thank you for Pak Budi and Pak Hendro for the insightful speech. My two question for Pak Budi regarding the sustainable aviation fuel. So my research also, one of my research focusing also to calculate how much biomass feedstock available in Indonesia, and the result is very huge, just as you mentioned in your slide. But I'm not considering specifically sustainable aviation fuel, but for the whole bioenergy in Indonesia. My question is about what is the long-term goal of sustainable aviation fuel for the trial itself? Is it like, I don't know, we cannot be forever in the large scale, but when you will it commercially and who will use it? And the second question, in the morning session, Pak Zainal from PLN say something about challenge regarding the supply chains for biomass feedstock. I wonder how Sipatra will solve the challenge related to supply chains for the biomass feedstock, because I think it's also one of your and yeah, and is it for smallholder farmers or is it for the farmer company? The second question, thank you, Pak Hendro, for very insightful goals from the governments. I brought that in your slide that government goal is 3% sustainable aviation fuel in 2027, and it will be used in international selected airport for the sustainable aviation fuel. You mentioned in your slide something like that. I just wondering why it's not international airport, why it's not used in domestic airports. I mean, rather than export to other country with very strict certifications program, why we are not using that in the national or the local airport? Thank you.
And what is your name?
Dwi-Cha, Pak.
Thank you. Is there any second question? Yeah, please. Thank you very much for your participation. My name is from Pablo. So I have a question for I have two questions. First is about the so what will be is there for the stock and also the for the just stock I think there's some lesson learned. There was a line from so from the regulator side, what will be the and second is what the EV. So yes, understand that the emission coming from out of the cars are shifted to the markets, right? And now, especially in Java, I believe that as far as I understand, the Java is still dominated fossil. What will be the strategy from Indian art? And how will you yeah. The first question is about our roadmap. We have started this initiative around 2 years ago, starting from both sides. We have passed our study and now in the development. Have an ID by the trigger of our development, as I mentioned, is
from the market itself, because we know that there is a global mandate plan to be activated massively, gap of supply there. So this is where we are coming, start from that. And then also now currently the activity stock supplier and also currently aiming of taker from outside Indonesia, of course, because we by the economics of this. Also, we need that national market. We of course have also the other side that the compliance is like stock, also the acceptability and also the life cycle assessment of the CO2 also. The target for us is to start it, but just to connect to your second question about the supply chain challenge, that's also one of the key points that we found out in our feasibility study before. That sometimes if we want to make it big, challenges become the supply chain. So what we are doing right now is we try to start with quite small size of capacity, but the strategy is to put the plan to be closer to the source of the feedstock, to the plantation area. So then the feedstock security can still protected to a manageable logistic need. There is some challenges. Some people say that okay, the economic scale might be then sacrificed because of that, but our aim is actually to have a feedstock security at the first one, right? And then also then we can have a stable operation, to have a capacity factor, a good capacity factor of 95% of the facility, in order also to have a long-term offtake contract with your offtake. So we start small, to I think answer your question, to protect that supply chain challenges. Because I mean we have found in the market the big plants have been operated that challenge at the end of the day is the feedstock. So the feedstock cannot supply properly, and the production of the facility also cannot fulfill the maximum capacity. So this is our first development, and hopefully can achieve our commercial production by 2029, and hopefully also we can continue the model, because I think one of the first model we start with small size of facility to mitigate the risk of the stock security and also thank you, Mr. Luki. Because we have a tight schedule, maybe Mr. Hendro can give a brief answer for the question.
Yes, I'm so sorry. I cannot hear very clearly, but I can maybe get a few. But one of question, if I am not mistaken, please, if I'm not wrong, if why SAF 3% only implemented in international flight rates. Okay, for this, the answer is the first one is because there is an international standard. So all of international terminal that serve international flight should obey International Civil Aviation Organization scheme. If I am not mistaken, the name is CORSIA. This scheme have mandatory for international maskapai international flight to reduce their carbon emission. So this is the first reason, and the second one, thank you for the input. Surely we will implement it in domestic flight as well, but we need like staging. The first stage is implement international flight, and then we will have to implement it in domestic flight. So we have a roadmap for the use of SAF state by state to keep the price of the ticket and operational cost. So this is my answer. Yeah. Thank you.
I'm sorry for Sir Adiman from Jakarta. Maybe the question will be answered by Okay, for the audience, give applause for our speaker. Because we are at the end of session, the last but not the least, I apologize for any mistake. I close this session. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. I give to the mother, the MC. Waalaikumsalam. Thank you so much, Dr. Yan. And please give a round of applause again for all the speakers and moderators. Now, I would like to invite Dr. Raaf to be our moderator and speakers. Token of appreciation for BRIN. For Mr. Hendro, could you please stay on cam? I'm gonna tell you our result. So we have here it's Aplication that have image of hotels of BRIN in the department. All right. Now for the and also by Yep. Okay. Thank you, Dr. Aham, Dr. Yan, and Dr. Budi.
Please give the warmest applause once again to this session. Ladies and gentlemen, we will proceed with the industrial talk session. We are behind the schedule, so for this last session, before the lunch break, we will need to adjust our agenda to be completed by 1 p.m. We are very sorry for this inconvenience and thank you very much for your cooperation. So this session will be guided by moderator Dr. Eka Rahman Priyandana. Dr. Eka is the head of Research Center for Electrical Technology BRIN. Dr. Eka, please come to the stage. Very much, Dr. Eka, to be our moderator. And this session, we will have two speakers. Our first speakers will be Mr. Budiawansa, as the Director of Chief Sustainability and Corporate Affairs Officer from PT Vale Indonesia Tbk. But please, I would like to confirm if you still have time to join us. Is it okay? So, we're very sorry for delaying the agenda. All right, so it will be Mr. Budiawansa, continue as the presenter. You can stay. I will call you again later. And next speaker is Mr. Yuta Kaneko, Product Business Manager from PT Sarana Laboratorium Instrumentasi Yogi. Please welcome Mr. Budiawansa and Mr. Yuta Kaneko. I would like to confirm once again, Mr. Budiawansa, are you okay to continue until the end and then have the Q&A, or do you prefer to have your own Q&A separate? You first. Okay. So, ladies and gentlemen, since Mr. Budiawansa have another urgent agenda, so we will have Q&A special for Mr. Budiawansa later after his presentation, and then followed by Mr. Yuta Kaneko presentation. Mr. Kaneko, is it okay for you? Mr. Kaneko, is it okay for you if we have Q&A for Mr. Budi first? All right, great. Thank you so much for your cooperation. Please give applause for all of us here. All right, please, Dr. Eka, the time is yours.
Thank you, MC. Ladies and gentlemen, good afternoon. Welcome to
this session. My name is Eka from the Center for Electrical. Today we will be discussing an important topic related to mining and sharing. It is my firstly, please give applause to our. It is my pleasure to introduce our speaker for this session. The first speaker is Mr. Budiawan Syah. He is Director and Chief Sustainability and Corporate Affairs Officer of PT Valley Indonesia Tbk. He has been having joined PT Valley since 2004. He has served as head of institutional regulation and licensing and other key positions, and he is currently focused on corporate sustainability and public relations. Mr. Budiawan Syah will present on the topic titled Sustainability Energy Program of PT Valley Indonesia Tbk. Without further ado, please welcome Mr. Budiawan Syah. The floor is yours. Yeah, go to the slide. Thank you. Let's go. I love the way it's set up. Sorry, like that. Yeah. Good afternoon. Selamat siang. Welcome to Jakarta for all of you that traveling from overseas. You can call me. Would like to deliver some sharing or probably that what we have been doing for more than 5 years integrated level and Indonesia. Past that the national nickel company, Canadian is company that operated at Sulawesi Island as part of the contract of the government of Indonesia since starting operations since 1970. So the Valley Indonesia, formally, I said that before that ECO, now Bidang Valley Indonesia, has been sectors, sustainability mining. There are many concerns, there are many challenges for the mining companies, especially. So that's why as always I said that very close to the deforestation, very close to the environment, very close to the sociality. But what is behind of the fields? Since we start our operation, Sulawesi, South Sulawesi, Southeast Sulawesi, and Central Sulawesi now, we operate our operation. So you see, this is our area where the contract of wood now becomes special mining license, the government of Indonesia. So Sorako operations that around 70 tons of the area. And then also Southeast Sulawesi that around 20,000 hectares mining, as well as Central. Next thing, you see, see that Sorako, South Sulawesi, that run by us, Valley or ECO in the past, then Southeast Sulawesi that we run business with the companies, and then also the provider with from Buayu, Zhejiang, and then also from Malang. Then Central Sulawesi also Kopro, and also with Gem. And another project that we developed now at Sorako, and then also in the Sorako outer area, explains public that one of the automakers that do. It's not only how to operate, because we talk usually the speakers here about the sources of energy, transition energy. So Valley Indonesia has been operating for the Sorako, then you see the challenge, the big challenge. More than 70% of the rest is for the support is never inside.
That's all very good technology that conservative. Now we will improve our plan and decisions of the for the side load line reduction. So until now, so that's increasing the intensity for the technology. Next, as I said, challenge is itself. So at Sorako, they are lucky to have design because of there are things that support them for the hydropower plant. But how about the others? Here, for example, at Sorako, it's not only providing the thing, but for BDI, the sustainability is not just, but the risk that is that start from the on. As we have been operating at Sorako more than 50 years, so this plant literally mining like very condensed, very maybe that for the environment, you know that where the mining location just side by side with it. Then, but the challenge is how taking care of the environment as well as the other aspect like social. So that's like a simple of people doing mining, how they transporting. So this what we demonstrate here to know that we do mining for sure, but so think about what we can give back to the problem. So this is a trend of the technology used for the big example at Sorako that reduced 365 of the megawatt from the hydropower plant. So there are 3 power plants there that supporting 100% of the smelter at Sorako by and then there are some okay, too fast. So there are another initiative that now for the developing of the project itself, maybe a several project coming to Sorako that they could from itself. For sure, those projects will require an energy, should have energy. The challenge here is the first from the process, second is from the energy availability. Treatment of the I use and provide it. You see here, there are additionals, and then that's why some of the initiative like operation and maintenance excellence that the improvement for the existing hydropower plant can increase another 50 megawatts and also put solar PV. And part of the study also operations in our basin. So you see the left side cover is there are several industries that we support the sustainability operations for Sorako, like oxygen side load system. So at Sorako, for sure that we need more additional energy, and the second one is for that agglomeration. So that's agglomeration for sure. Dry technology and of the technology that's more creative. So see here that tends to decrease of the energy consumption there, but for overall, that later on in our GP, that other company, I mean, for developing that we are going to supply them the energy for like it's free but adjustment for our optimization. So as part of our decarbonization program for smelters, so the Valley is technically mining company. Since the beginning,
established. The value is starting from mining until the end of the domain of plant. So electric battery is one of them. So see here the decarbonization of so as we have several scenarios, but if we now what we're doing now is value creation. So what is the meaning of value creation? So you want to put or develop something creating value value for the so that's why the Bali still adopt the concept of the offset carbon. So the challenge, as I said, for this level, the energy itself. For example, at Sorako, there are more than 200 level. One is level. One of the setting now. From level, from the junction. So that's one example for the nation we call. It's like those things, you know, that sustainability not just yesterday. We demonstrate this for decades, and then now also say that sustainability is performance for I see that is called 7 name that they are in the road is connected to road is so now know that one of the real about so now the process of getting sustainability transport by one of the sources that load was mining. I think all the so how thing. Well, so that means every operation. Talent was good. I back to the director. Thank you, Bapak.
Thank you very much for your great presentation, Mr. From your great presentation, I have a question. I have a question. In simple terms, what does sustainability mean for farming? Normally, people looking the sustainability from the environment side, but we should looking also another aspect like from the social and the people. People for us is a center of the business, right? For the operations that we have been doing, as I said, 58 years, and all this thing. Yeah, sustainability meaning that we have been operating this become embedded to organization. So, if I may share, mining is quite identically the open area of the surface of the earth, right? Forestation. And then you know, from the 70,000 hectares, then total area is 118 hectares. 118
1,000 hectares of the area of PDP has, it's only 46% from those area, 46% from 100,000 is mineable area. So where is the rest go? The rest is a buffer zone. So that is mineable. That's the incentive from us. People imagine that, oh, the Republic Indonesia has big area for mining. No. Only 46% up to 48% of those area is mineable. The rest is buffer area. Why is buffer area is important? Protect the ecosystem, protect the balance with the environment. The second is also that I can share is we implement progressive reclamation. What is the progressive thing? I put my memories 22 years ago when I just started as engineer. So there is one expertise geologist from Canada. His name is Mr. Wahid Ahmed. He's teaching us how is the nickel laterite formed. So the more you open the area, the more you bring risk to the environment. Because of naturally, laterite is the thing from the glass. When you open it, can the reactive rapid reactions become corrosive. So how we manage? So naturally, it's there. Because we know this is harmful for the environment. So that's why we use the approach of reclamations, progressive reclamation. What is progressive reclamation? We open it and then we close it without waiting the mining is ended. And it's possible. I invite all of you, if you have a chance to visit Sorako, you will see how the progressive reclamation happened there. So those things from the angle of the environment, which is the backbone of the sustainability, and then for sure that we are not perfect, we are open for the inputs and the feedback, because then I believe that system and then also open, transparent is the baseline for the sustainability. My second, from all the achieving, which action has been the most effective for change or improving? Yeah, my background as an engineer, so I remember that when we decided to shut down the fuel energy boilers that fuel-based energy, then why we invest those equipment and then at the end we shut down. And then the second one is when we have two options, when we expand the hydro power plant, the third hydro power plant at Caribbean is produced another 70 megawatt. At the time, the coal price was very cheap. So it meant that if we are going to be from the economic point of view, financial, I will choose to build the coal power plant instead of hydro power plant. But at the time, company decided to choose that hydro power plant. And then that is very significant. And then from those combination energy that creating, that now, since a couple of years ago, all the energy for smelters, there are 4 furnaces there, 100% from the clean energy, from the hydropower plant. The second is those excess energy from hydropower plant, we operating is zero carbon boiler. Where is the energy source? From the hydropower plant. And then now, those smelter also produce heat, generating heat, right, as waste heat. So now the team is working captures that waste heat energy, reuse or recycle again. And then also reducing the moisture content in the product mining is also important. Prevent from the add more carbon for the process. Those heating is very, very significant of the very much. But and my question is, what is the biggest challenge and in energy program regards to finding? And what is your top priority? Speaker before is talking the biomass, right? The challenge for the smelter is the process itself. I mean the dry methodology. So one example is we still have another concern for the reductor. Because of the reductor itself still use oil and small portion of coal. So this is our teams working from the engineering point of view, how we substitute these carbon reductor sources. So one of the possibilities is the team already trial the biomass, which is a very, very good result. So we trial 1,000 pounds per month, and then bring significant results reductors to place that one. So this has become our priority to replace the carbon reductors in the process, right? This is important because of having that low carbon like gas or biomass is the key also for this industry. But the challenge is, as I said, that the previous speaker says, it's about the logistics, right? So you can imagine biomass with that size and then the volume transporting from Sumatra, Kalimantan to Sulawesi is not feasible. So that's one challenge that that we're facing today. So we appreciate some initiative is building the biomass plant that very close to the smelter. As you know that there are many smelter also has been built in country. So this is become good opportunity. Second one is about the optimizing now the energy that we use. As I said that now we succeed to do the trial for the waste heat recovery, and then we are going to continue again to maximize this waste heat recovery, and then also with our waste heat. And then the third one is from the raw material itself from the ore of the mining that still contain that water mix moisture that equivalent from high carbon is required. So those big chunk that we work at now, right? In order to use on the maximum. So thank you very much. Then, ladies and gentlemen, I would like to conclude. Maybe from the audience, you can ask a question for Mr. Answer.
A very concise one.
Concise.
Yeah. Yep.
Okay, not yet. Okay. Just so right. So smelter industry, there are many smelters that is. So it's like there are many suicide, but we believe that you can demonstrate good mining practice, good integrated smelting process, respect to the environment, people, and social. So don't forget the two elements there, like people and social, are important for to the environment. There are many challenges for the environment, but don't forget those two elements. Sustainability is talking about those three big elements, right? If you would like to sustain the operation, so as we always said that people is the closest impact to us, and then also the social also the closest affected also from the operation. So if you have any doubt, that you can directly ask the questions, but again and again, better can become the centers of the green energy and then battery ecosystem later on. You will see use of abundance of resources here. Now it's matter of we can be teacher or not. Can the teacher use be mining responsible? Thank you very much. Thank you. Ladies and gentlemen, please give a round of applause for Diamanatkan.
Since Mr. Budiawansyah is giving, I'll forward a little bit, and I would like to invite Dr. Aam, as Head of Research Center for Transportation Technology, to deliver our symbol of gratitude for having you today and for having your presentation with very informative information. Thank you so much, sir. Despite your, I believe everyone here very busy, including Mr. Budiawansyah. Thank you so much for sharing your time with us. From PT Balai Indonesia. Yeah, let's have a photo so that we have all the speakers and moderator and Dr. Aam together for this session. All right, please give applause to this session for special for Mr. Budiawansyah. Dr. Aam, can return to yours. Thank you very much, Pak Budi. Yeah, okay. So, ladies and gentlemen, please hang on. We still have one more presentation. Mr. Yuta, we are very sorry for this delay. And yeah, so please continue, Dr. Eta.
Thank you very much, Sophie. Good afternoon, Mr. Yuta Kaneko. Mr. Yuta Kaneko, he was graduated from University and joined Tokyo Corporation Japan 2011. He worked at Osaka branch office and Tokyo branch office at the sales firm. He started work in Tokyo, Indonesia since 2022. And now in charge of product business strategy manager, Mr. Kaneko will present on the topic titled Importance of Wetland Consideration in Motor Loss Navigation, Measurement and Analysis, including without further ado, please welcome Mr. Yuta Kaneko. The floor is yours.
Thank you for your introduction. Could you combine? Selamat siang. Before I start, please get time to introduce our solution for needs. Good morning, ladies and gentlemen. It's a great honor to speak at the international conference on the sustainable energy and application. And today, my name is Yuta Kaneko from PTTOP Electric Indonesia. Today, I will talk about the importance of the wide-band consideration in the motor loss evaluation, measurement measurement and analysis, including rising loss. For we start, let me ask you a question. Simple question. The motor efficiency exceeds 100%. Simulation and measurement do not match. Motor and inverter efficiency value vary, depends on the equipment. There are days my presentation. First, I will introduce the background of the market trend. Then I will explain the measurement challenges, especially at the high frequency. Finally, I will present our power measurement solution for the accurate inverter and motor loss evaluation. This agenda, before I move to the main topic, let me briefly introduce our Yogi provides electrical measurement solutions, the four main products, for and package testing, recorders, data loggers, power analyzers, and maintenance solutions. Next, please. Also, we have the 11 countries branch the world. In Indonesia, there are two offices, Jakarta and Surabaya. And also in here, we provide after service repair and calibration. And also we have the training center. Yeah, we can provide a specific program for the customers. Okay, from here, it's the market trend and measurement impact. With the growth of the XEV market, the move toward the sustainable society, high efficiency, compactness, and a lighter weight. As a result, motor speed are increasing, battery voltage are higher, higher switching are operating like a SIC and a GAN. These changes create challenges in EMC, summer management, solution, and especially the motor loss measurement. Without accurate measurement, development, the result cannot be correctly evaluated. From the market, we often hear motor loss simulation do not match measurement. Loss maps and the summer behavior do not correlate. From the measurement perspective, this raises an important question. Are high frequency inverter loss being measured correctly? Here, it challenges in particular carrier loss and the linking loss. These high frequency loss are often underestimated or missed entirely. To get reliable values, there are two things that matter. First is understanding the DUT. Second, required measurement performance for motor loss. Then to address this, we first need to understand the device under test. This is a motor bench, which have Hyoki, Japan, around the center. Also, we do not manufacture motor benches. Hands-on evaluation is essential to fully understand really measurement challenges. Key points in the efficiency and the loss measurement system. This slide shows the power measurement points and loss from the inverter input to motor output. The key question is that can we accurately measure inverter output power? Inverter output power consists of the fundamental frequency components, carrier frequency components, and ringing components. Because the inverter output is a PWM waveform, it contains high frequency components caused by switching, motor capacitance, and the cable inductance. These components make accurate power measurement very difficult. In this slide, the PW8001 is our power analyzer model number. With a power analyzer on the motor bench, the PSE, the power spectrum analyzer, can be clearly evaluated. It provides a high amplitude and a phase accuracy across the wide frequency range. Here we look at the ringing loss measurement. Once again, here there is a system: load inverter, test motor, load motor, and torque sensor, and measurement beam station, and power analyzer, and control PC. This is a system. Using the power analyzer, we evaluated inverter output power, including the ringing components. As shown here, we confirm the ringing loss 14.9 watts, about 7.4% of the total motor loss. or roughly the 201 watts. This loss cannot be ignored. From this result, the required measurement performance becomes clear. Wide frequency band, phase accuracy to high frequencies, noise immunity, and high measurement accuracy. Phase accuracy to high, yes. Phase accuracy is the most critical factor in the power measurement. As shown in the power calculation formula, even a small phase error can significantly affect power result. I'm going to show the phase effect. At low frequency, the impact is limited. However, the high frequency, the same phase error causes a much larger power error. You make an example. Let's look at the concrete example. Frequency is 300 kilohertz and the phase angle is 88 degrees. And compare to the other products, the phase error are 10 degrees and the resulting loss error about 300%. Our solution is a phase error 0.03 degree, loss power about 3%. This difference completely changed loss evaluation results. So again, there are 4 kinds required the measurement components. The measurement solution to address these challenges, we progress a solution combine PW8000 power analyzer and high precision power measurement unit and high accuracy current sensors. This configuration enables accurate evaluation of the high frequency inverter loss. The summary. Today's summary is accurate high frequency inverter loss or evaluation that requires wideband, phase accurate, noise or robust, and power measurement to close the gap between simulation and the measurement. Thank you for your attention.
This gives us. Okay. Thank you, Mr. Kanu. Is there any question for audience from the Kanu?
That the measurement is defense domain, right? For here, the fundamental. The carrier is usually in PINL and fundamentals in SINWEB. The question is how the measurement will be okay if the inverter modulation is spectrum. The spectrum is truly mathematically to determine the moment should be what's so it's the will be okay, but it's common. So, my name is Christian. I am from the FN. For your question. To be honest, the inverter limited motor and your question is a control. So, see, based on the all the measurement instrument company, we provide the instrument and also result. But result is important for the control setting. So the what angle, the inverter setting, the model and combination. So I think it's difficult to answer that correctly. Not correctly the specific number, something like that. Because of course we have the many experiment in our lab, but each component is different. Then also the inverter and the motor is not a single how to say, the both unit must get a combination result. So our solution is a freeze measure before inverter, after inverter, and also the motor. So the total the result can be analyzed what is suitable setting something. Okay, that's you. Thank you. Assalamualaikum warahmatullahi wabarakatuh. I'm Subhan from Universitas Indonesia. Currently, I am develop electricity system model in small island, and I want to know about the probability measurement data, how different of the real electricity behavior of PV and battery and diesel system in small grid compared to the assumption for typically used energy planning model, and how can it get corrected? Thank you. Can I ask the again the you sorry. Currently, I develop the electricity system model for small island. Yeah. So from POT chairman vice data, I want to know about the difference of the real electrical behavior for PV battery and small diesel system in small grid compared to the assumption for typically used to energy planning models, and how can this gap be corrected with your advice? From the I'd like to provide our experiment in HQ. We have the off-grid system in HQ, the solar power, and also the EV and the ESS and charger. So that is one of the experiment our side. Then to check the actual and also the compare with the specification, the PV system and the grid system. Then at the time, we are not only the power measurement, we also using the temperature and the humidity and the weather condition. So to clear the to solve the gap between the ideal and also the actual, we need to measure not only power. Other factor is also important. Environment, because the battery is one of the effect from the temperature function, something like that. So our solution is not only the product, and each product can combine with the software to analyze. So something like that, we need to provide not only product, but also the to analyze software and the output. I think the data could I discuss with you direct the answer. Okay. Thank you so much. Thank you. That's all. Oh, no. Okay. Thank you, Mr. Nico. I would like to conclude give Q&A session. Mr. Ganeso, Mr. Kaniko, discussion period shows that accurate wideband with accurate vision is no longer optional but essential for reliable motor and okay, ladies and gentlemen, please give a round of applause to our Mr. Kaniko. Thank you very much. Arigatou gozaimashita.
Okay, ladies and gentlemen, please give a round of applause to this session. Thank you very much to Dr. Eka and Dr. Eka and Mr. Yuta. Can you please stay on the stage? And I would like to invite Dr. Aa to again deliver our people of gratitude for having our speakers as well as the moderator here to Sir Haneko from PT Sarana Laboratorium Instrumentasi or COP, and to our moderator, Dr. Eka. Right, and another group photo. All right. Once again, please give the warmest applause for this session. Thank you so much. Okay, you can return to your seat. Yeah, thank you very much. Ladies and gentlemen, the morning session has now come to end. Please give a big round of applause to all of us for a very incredible enthusiasm and cooperation, both online and offline, especially since our agenda is behind the schedule. We are very sorry for that. And thank you so much for hanging on with us. Thank you so much. Once again, committee, please give applause to the participants of ICSEEA 2026. All right, our next agenda is lunch break to recharge our energy and prepare for the parallel sessions. Lunch will be served at Trembesi Cafe, located on the left side as you exit this room. On the left side as you exit this room. And since we have sponsors booth ready outside, we have 3 sponsor booths here. PT Quantel, Chroma Indonesia, a tech company that sell high-end test and measurement gear for electronics and automation. Second booth is PT Sentra Surya Eka Jaya, a company that design and manufacture specialized armor and tactical vehicles for military, security, and special purpose operations. And PT Sarana Laboratorium Instrumentasi or HIOKI, a supplier of laboratory instruments and equipment of electrical measurement tools, providing test methods, analyzer, technical support to research labs and industries. We kindly invite all participants to visit the sponsor booth before or after your lunch to get to know their product or technology, because maybe you can collaborate in the future. During lunch, this room will be reset up for the parallel room. This room will be reset up for the parallel room. Thus, we would like to ask for your cooperation to take your valuable personal belongings with you when leaving the room for lunch. Because we will divide this room into 3 parallel rooms, please take your belongings with you when leaving for lunch.
We would like to remind about the updated schedule at ICSEEA 2026 website. Then click the menu announcement and then use it. And the parallel session is expected to start at 2:10 p.m. And I will kindly there are several rules that I want to talk about. And one of them is the online participants, please follow the format, article ID, _name, topic. As example,
62_Novika_late energy. Second is, during parallelization, participants are expected to attend their respective groups and are on standby for the scheduled presentation. So you are not expected to be jumping around, break out, and break out. And the last one, there will be an awards for 5 best presenters and 10 best papers with interesting prize. So please do your best. Oh, if you have any question, you can please contact the organizing committee.
All right, so I'm Novi and my partner sign off for today. Enjoy your lunch and enjoy your parallel session. Thank you very much.
Founded in 1994, Chroma AT Incorporated, marketed under the brand name Chroma, is a world-leading provider of test and measurement technology, automation integration, intelligent manufacturing system, and test and automation turnkey solution. Over the last decades, Chroma has grown significantly as a Chroma Group covering semiconductor and wireless testing, automation, AI, powertrain, and digital signage. Now, there are 9 major companies under Chroma Group operating worldwide, exceeding 3,000 employees. Chroma's market focus has evolved with global technology trends and in the IT industry and progressed to semiconductor and communication test solutions. Green energy and communication. Our test application expanded to clean tech industry, market for AI, advanced packaging, energy storage, life science, where the growth opportunities lie ahead. Significant markets served by Chroma include semiconductors, photonics and LED, photovoltaics, video and color, flat panel display, power electronics, passive component, electrical safety, green battery, electric vehicle, thermal electrics, automated optical inspection, and intelligent manufacturing system for ICT tech industries. Chroma's vision is to empower future technology for a better world. We believe in the truth of measurement and the trust of partnerships. Using the most advanced solutions, we test and measure the quality of clients' products with the ambition of making them better, more effective, and ultimately thriving in the marketplace. By delivering truly constructive, open, and trusted partnerships, we enable the development of innovative products for the betterment of society and the world. Chroma enables quality innovation every step with reliable solutions. We have developed more than 100 core technologies that serve as cornerstones for new technology development, more than 1,000 patents worldwide. Chroma nurtures a brand one of innovation, collaboration, and trustworthiness to ensure the performance, quality, and success of technology industries. With continuous leadership in high power and high precision technologies, Chroma gains its competitive advantages. Chroma's performance has been recognized with several honors and awards, including Best Big Cap Company, distinguished Taiwan Middle Stand Award, distinguished Enterprise Innovation Award, Harvard Business Review Taiwan Top 100 Best Performing CEOs, Semi-Industry Contribution Award, and Top 40 Best Taiwan Global Brands. Chroma has branch offices in Europe, United States, Japan, Korea, China, and Southeast Asia, where we support customers with local value-added service and unique test and automation turnkey solutions in the fields of e-mobility, communication, and green energy, making our everyday life greener and smarter, now and in the future. Chroma, advancing excellence.
Tiap hari, tiap istri, banyak orang. Ada yang lama dan yang baru. Ada yang sempat sendu,
ada juga yang buru-buru. Semua ada ceritanya. Yang ngasih energi buat gerakin hari-hari kita. Seringnya sederhana dan yang kecil, tapi membesarin semangat. Atau hal-hal yang tak terduga, tapi ubah sesuatu di dalam diri. Dan nggak cuma di daratan. Di laut, ada cerita teman-teman yang bergerak bareng nelayan ke jaring berkah. Di bandara, mereka yang selalu sigap buat nerbangin energi di udara. Saya rasa, detik ini pasti ada aja energi mengalir, jadi penyemangat buat terus melayani sepenuh hati. Timburin rasa dekat, obat di tiap perjalanan, sepanjang Indonesia. 68 tahun dan berkelanjutan. Pertamina, energizing Indonesia.